So I think one of the things with vectors is that it's often you overthink what it's about. Now I want to show you that the difficulty in vectors usually just arises from negative numbers and fractions. That's where the difficulty is. Other than that, it's a pretty straightforward, easy concept. So everybody press like and let's log back in. We're going to learn some bit about vectors. Now vectors always comes. Vectors will come. It will come. It will come. And before we talk about when vectors come, two things to mention. All the past papers, www.curwenspringer.com. If you've been to this website before, say something. All the past papers and past paper solutions are there. I updated it. There were some gaps in some years that was getting missed out and that kind of thing, so I updated it. Let me just show you real quick. Those of you all, when we swing back in for the multiple choice, and you'll be coming in hard for that multiple choice. Just let your neighbor and your friends know. Let your family and them know that we're coming in real hard for that multiple choice. So when you come back in, we will have things waiting on video, boy. We gonna have some things waiting on video. So this is the past papers, and I went through, I checked through this. So you could go here and you'll see this. You'll see how much raw papers are on this now. It's already one of the places you can get the most amount of free past papers so far. And the ones that highlighted are ones that I'm working out solutions for and stuff already. So we have maths, physics, biology, chemistry already in the dance. The physics multiple choice not finished up yet. I still need to go through this and finish it up. But you go on the multiple choice bank, let's say the bio, and you can go through and you can do the multiple choice. But it's not about multiple choice today. So let me not waste no time talking about that multiple choice. Far from now. What I want to show you is that on the past papers, you can just click maths and you can get all the work solutions here. Click on them, you can get your paper 2 solutions. Understood? Understood. So I have them for most of the years that you would need them for. There are a couple of years, May, Junes here that have some work to neaten up. But like all the recent 10 years, you can check through them, good to go. So definitely run and check this, right? I'll remind you all at the end of the stream to go and run through it. You have physics, POB, add maths, bio with solutions, infotech, chemistry, social studies, and some of them have their have the multiple choice for them. Catch it, so you can go and like run the physics multiple choice. Click on that. Let's say you want to run the chem multiple choice. Click on the chem, and you can go through different topics. You can take off the topics you don't want to get, but you can go through different topics and pick your answers. It will tell you what is wrong and why it's wrong and give you them kind of thing. But we're going to swing back for that later. Right now, maths is tomorrow. So that's what we're getting ready for. So vectors will come, and don't overthink vectors. If I switch this, let me switch the template here to a grid, right? Actually, let me just use this. Let me just use this drawing thing. And let's say I have this, and I have my line. Let's say each one is 5, 10, 15, 20, 25, 5, 10, 15, 20, 25. Of course, this will be 0 and it'll be -5, -10, -5, -10. If I create a random vector like this, a random vector like 2, 3, do you know how to draw that vector? Technically, we don't know how to draw that vector because it doesn't have a spot that we want it to go from, 2, 3. So that vector could be in any location. That vector it just means go across 2 and go up 3. So you're going up 3 and you're going across 2. So if I start here, I go across 2 and I go up 3. That is the vector. That is that unnamed vector. I could call it vector U if I want. That's U. That's U, right? I could also have you all understood that? I could also have a vector V. I could also have a vector U situated here. Let's say I go across 2 and I go up 3. This could also be U right here too. Like you right there too. Notice how they are parallel to each other because they're the same vector. So it's not too deep. It's not too deep. What happens is if I'm using like points. So if I'm using points on the graph, like let's say I have this point here, and I decide this is P, and I say that P to Q is the vector 2, 3. Well done, I have to start on P. I have to start on P and go across 2 and go up 3. So this, by knowing this, I'm able to figure out where Q is as well. And that's the vector from P to Q. And that's how you write it, PQ. There's also things called like pose. So you might be saying, so aren't I supposed to start from the origin? Yeah, that's a special type of displacement vector. These are displacement vectors because they cover some distance at displacement. So if I have OP, in this situation, OP is this vector here from O, the origin is like O then to P, that's that vector. If I have OQ, then I would be doing from O to Q, like that. If you all understand, say, I understand, I grasp that. So we can have very simple ideas with vectors, very simple ideas. One of the simple fundamental ideas that I introduced some time ago is the idea of position vectors, like OA. A position vector to the students. So what is a position vector? 5, 6. Actually, that's what I wanted to talk about. I wanted to talk about the triangle formula with position vectors. There's a way we can relate a displacement vector to a position vector. So let's say I have this here, and this is A, and this is B down here, AB. Tell me what the vector AB is. Just watching these squares. Earlier I was saying 2, 5 and all kind of thing, but I'm supposed to be counting in 5s. I'm supposed to be counting in 5s. I'm saying 2, 3, 1, 2. But I have 5s here. You only realize that. But anyhow, let's say somebody tell me what AB is based off of the scale. Let's do this one right. Well, I've seen people saying, well, they're saying for AB. Come on, let's do this one right. We had to watch the scale, right? So you're going from A to B, A to B. So it's 1, -2. So if you all have 1, -2, I'll take that. But the scale is actually 5. You all want me to put this? Let's put this scale in ones then. So it will look that confusing. Because that was actually 5, -20, right? But let's change it to 1, 2, 3, 4. 1, 2, 3, 4. So I can erase you, bro. So 1, 2, that's -1, 2, -1, -2. I had to make little notes on things that I want to just tweak on this. Good. Yeah, so AB is 1, -2. Everybody understand why? You have to go across 1 and then drop down 2. So it's 1, -2. 1, -2. Everybody press like on the stream, share it up, share it everywhere. Share it everywhere, indiscriminately. Spam this stream with your friends. So O is from the origin here. So I could say OA would be that. I don't know why it's not hitting exact. These things not behaving themselves right now. So that's OA. And then I can also do OB. OB is that. But this is OA. So what is OB? OB is go across 3 and go up 2. What is OA? Say it in the chat. OA is what? OA is 4. Sorry, 2, 4. But anyway, just for kicks, what's the coordinates of A? This is found on 2, 4. 2, 4. What's the coordinates of B? 3, 2. Do you realize something familiar here between the coordinates and the vector itself? Yeah. The position vector is actually the coordinate written in a vertical format. So if you're not getting this, I want to say you're overthinking this. If you're not getting this initial part here, you're way overthinking it. Because ask anybody in the chat who write in the answer. There's so much people writing. And this is a real simple concept I'm talking now. I ain't talking anything fantastic. I'm literally saying that from O to B, you'll have to jump across 1, 2, 3. So write 3 there. And then you have to go up 1, 2. You're overthinking it. If you're not catching it, you're overthinking it. You're going too far. Come back, come down from come down from there. So the coordinates are related to that. Let's pick up in a new spot again so you can see. But I can't take too long. I remember I have some people here who understand this and they're waiting for the good, they're waiting for it to get good. They're waiting for the tough part because this is get good. Trust me on that one. So let's say this is X. This is 1, 2, 3. This is 1, 2, 3, 4, 5. And I miss 5, 6. Let's say this is AB here. Just by watching this, can you tell me what AB is? A to B. Because this is A, this is B. What y'all think AB is? Just by watching it and counting these squares as they go across, as they go down. As they go across and as they go down. What is AB? Just by watching it. Just by watching it. Just count these squares and see what you'll get. That means you'll have to go AB. You'll have to go across 1, 2, 3, 4, 5, or 6 minus 1 is 5. I'm getting 5, not 6. You all put 6 because you see 6 there. You already started on 1. So you actually go across 5, and then you have to go down 2. That's 5, negative 2. 5, negative 2. You're going down. So going down is a negative movement. This number here talks about the Y, whether you go up or down, and this number here talks about the X, whether you go left or right. What will be BA then, class? BA will be what? If I want to start on B and go back to A, what is BA now? Well, BA, I'll have to go backwards 5. So that means it's going to be negative 5. And then I'll go up. Up is a positive movement. So backward 5. Catching it, class? What is the shortcut for this thing, man? I forget what is the shortcut for this. L. Yeah, so I had to go backward 1, 2, 3, 4, 5. And then I had to go up 1, 2. Are we cooking? I think we're cooking. So up 2. So you're going to put 2 there. 2. 2. Now watch this. What you notice about this as well as this. What you notice? This versus this. And this is AB and this is BA. Notice how these signs just switch? Is that making sense? Class, are we cooking? I think we're cooking. I think we are cooking. Now, I did something before. I said if I put a number there, I'll call that number O. I'll call that number O. Well, this point O. O for origin. The coordinates of the origin is 0, 0. And any vector that comes out of the origin is called a position vector. That's just given a specific name. So once a vector starts with O and goes to P or Q or R or S or A, that's a position vector. And what I'm saying for the position vector, all you need to do is watch what A is, 1, 3, and that's the answer there, 1, 3. The position vector is the coordinate written in a vertical form. Catch it now. OB is equal to what then? What is OB equal to? OB, you'll have to go across 6. This time you'll choose 6, class. And go up 1. Or you can just read it off. There's a 6 here, right? 6, 1. 6, 1. Now there's a way to hook. There's a way to attach the normal displacement vector to the position vector. And that's called the triangle law. But it's based off of the key idea with vectors. And I always say it. So can somebody tell me what I always say? The key to vectors, other than understanding that the miserable part of vectors is the use of negative numbers and fractions. The key to vectors is finding another way. Well done, Janelle Francis. Finding another way. That's one of the key ideas in vectors. You're going to use this idea in the exam. And if you just understand that, and you don't know no formulas, but you're good in maths and you just understand that, you would be able to conquer vectors one time. Because that's the big trick in vectors, really. Finding another way. A lot of you are writing that. Where Malik? Malik crack up. Malik, he got to go already. So he probably rock back right now, sipping some coffee somewhere. I don't know what he's doing. So that is AB. if I want to get AB, look, lock in everybody. I can say that AB, can you agree with me? AB is the same as if I go from A, I start off at A, and I go to what? O, which is another way. And then I pick back up at O, so add on O, and I go to B. But I already know what OB is. OB is what? 6, 1. And what is AO? AO is it 1, 3? No. See why? This is OA. The reverse will be negative 1, negative 1, negative 3. Negative 1, negative 3, and that will give me the answer, you know. Negative 1 plus 6 is 5. Negative 3 plus 1 is negative 2. Isn't that the answer? Negative 1, 3. That's not the answer. So I don't know what happened here. I bounce my 2 somewhere. 3, 1, 1, 3. 1, negative 3. Oh, this was negative 2. Oh, yeah, it was. Yeah, it is the answer. I was watching the wrong thing. So good. I didn't bounce my 2. It is the answer. We work in. AB is 5, negative 2. And look, I got AB is 5, negative 2. Now, there's a neater way to do this. This is correct if you understand this, you work with that. But there's a neater way to do it, like in terms of the statement itself. What we do is, that's not, I'm just writing some things here. What we do is, we put OA instead. One time. Stay with me, people. Remember I had OB, I know I had here, but I say go from A to O, I had AO here. But isn't AO the same as the opposite of OA? So can't I just put negative OA instead? There? Negative OA. Because we had to switch these to negative signs. And can't I just rewrite this in a better way as AB is, I'll put the OB first, and then put the negative OA. That's called the triangle law. So the format is a little neater. But if you understand the keys of finding another way and you could do the OA, that's cool. But this, a lot of you all will be familiar with this. This is called the triangle law. Where you put the second one, watch out, the second one comes first. Yes? And the first one comes second. So OB minus, but there's a minus sign in between. So if I do it like this, I'll still get the same answer. I'll get 6, 1, minus 1, 3, and I'll get 5, negative 2, which is the answer. Triangle law, ladies and gents. You all want to try a question with the triangle law? Let's try a question with the triangle law. Let's try a question with the triangle law, because this might be coming for your exams. Let's say the vector PQ, OP is equal to 10, negative 3. And actually, let me give you a full question. The points P and Q are negative 2, 10, and 5, negative 5, 1 respectively. So I made this board like about a month ago, about 2 weeks ago, 2 or 3 weeks ago. So this board is freshly made. I'm just kind of tweaking it so I can always use it while I'm online for these kind of things. The scribbler. That's why I see Cohen Spring in the background there if you watch really carefully the student tab. Anyhow, the points P and Q are these points respectively. Find OP, OQ, then PQ. Come on. So if you see this in your exams, what are you going to do? If you see this in your exams, OP, OQ, and PQ. So I want to propose to you that A and B are the easiest questions you can get for CXC. Literally the easiest thing in the exam that you can be asked, and it probably in your exam waiting right now, is to find a position vector. And my people perish for a lack of knowledge. You don't even know that is the easiest things. Because like, I actually mess up the way I write the question here. Because they would actually not write it like this. What they'll have negative 2, 10, and what was it? Negative 5, 1 I had here. I hope it was negative 5, 1 they'll have it flat. So I was also thinking about the answer. I put it like that. It is the easiest thing. They are going to give you remember I told you that. In vectors, check and see this. They give you a point, and then they ask you the position vector for that point. All you have to do is write back the point like this. You all didn't see when we was doing that just now? That's the answer, you know, right here, OP. Remember I told you B was like 6, 1. So OB is 6, 1. That is it. So what do you think OQ is going to be? OQ is going to be what? I need a next color for this highlighter. Yes, OQ is going to be negative 5, 1, and just write it vertically. Please don't lose that 1 mark, because that's a free 1 mark. You will cry if you see I doing that solutions and you see that free 1 mark there. Trying to stop the tears. Trying to stop the tears from falling. So PQ, we can rough him up there with the triangle law. We could give it the triangle law, PQ. Remember the triangle law was in the form, if I had AB and I know the position vectors, I could say the second vector, OB, that one is positive, but the first one I want the opposite, so I'll say negative OA, like that. That's our triangle law. So if this is the triangle law, how am I going to put it into play? How are we going to put the triangle law into play? Well, we'll just put the second one, OQ minus OP. And then what we'll get? We'll get negative 5, 1 minus negative 2, 1. 10. Negative 2, 10. OQ minus OP. And it works. So negative 5 minus negative 2 is actually negative 3. Because that's negative 5 plus 2. And 1 minus 10 is negative 9. And those of you all who had negative 3, negative 9 from a while ago, like Justin Bieber and thing, cooking. Cooking. Are we cooking, ladies and gents? That's coming. You're going to get something like this. Make sure you can make use of the triangle law. So the key to vectors is really just finding another way. And the triangle law is an example of how you'd find another way. The people them want next question. The people them say, run it again. So let's say I said we have the points L is found. Let's use L. Let's say M is found at 4, 0. And N is found at 2, 7. Find the value of the following vectors. A, OM, B, ON, C, MN, D, NM. Let's go. Let's go. Let us go. Let's go. Let's go. The easiest question in the entire paper is in front of you, ladies and gentlemen. The easiest question in the entire paper. When you have to find a position vector and they give you the coordinates, what they're doing is telling you, look, the answer right in front of you. They're actually showing that, watch, you didn't even revise your work. If you get it wrong, they're showing you, watch, you didn't even learn nothing in vectors. So OM is just 4, 0. Once you have the coordinates of M, this is M. So OM is just 4, 0, as I know, you ain't believing, man. So this is 2, 7, straight. So then what is MN? MN, I could use the triangle law. Since I know the vectors OM and ON, anytime you know the individual position vectors to the letters, use the triangle law. You're going to say ON minus OM. Then you're going to be like, okay, fine. ON is 2, 7 minus 4, 0. And I end up with 2, I get a negative 2. Negative 2, 7. Anybody cook up that? Yeah, I've seen some people cook up that. Now, NM, I could do two things. I could do the long thing of working it out. I could say OM minus ON, so it's the reverse of that since this comes second now. Or I could realize that it's just the opposite of this. It could just be the opposite. NM, it will be negative MN. Why is in the chat if you agree? The reversal. You hit him the reversal. So it's going to be negative, negative 2, 7. So in the end, NM is just 2, negative 7. Remember that. Once again, if I told you that AB, if AB was equal to 2, 3, then BA would be equal to what? Negative 2, negative 3, right? You all remember that? Or if PQ or if PQ was 5, negative 2, then QP is negative 5, 2. Don't swap the numbers, swap the signs, switch the signs. We cooking? So if this is vectors and you're starting to understand it, why do people get low marks in it? Well, wish I could tell you that was all. That's not all. That's not all to it. So like you can find halfway, you can do a lot of different things. So like I can say if, you allow me to make you a nice one, if P is, let's say P is 2, 4, and Q is, let's say Q is negative 4. Let's say Q is 4, negative 8. Find, I'll give you an easy one. Find an easy one to start with. OP, then they will usually just give you one position vector. Then they'll give you like PQ, and then C. Find PM, where M is the midpoint of PQ. And just remember, we are supposed to do all of coordinate geometry. We can do that, we can get on to that yet. So coordinate geometry could come into play here. Coordinate geometry can come into play here. What is OP though? OP is simple. OP is just gonna be what? The 2, 4 I told you all. You just take this and make it vertical. What about PQ? PQ, well, we need the triangle law. We need the triangle law for vectors. PQ is 2, 4. No, let's write the formulas so we see that a little better. It's actually the other way. OQ minus OP. I know what OP is. I know it's 2, 4. And I also know that OQ is 4 minus 8. 4 minus 8. So this is going to be 4 minus 2 is 2. Minus 8 minus 4 is negative 12. A lot of people have it cooking in the chat, boy. This is one of the most amount of cooks I ever seen alive. Real cooks in this live. Okay? So this is 2, negative 12. Now, how you get the midpoint? How you get the midpoint? Just to add a little visual to it. Just add a little visuals to kind of like give you an idea what's going on. 2, 4 would be like 2, 4 somewhere up here is P. And 4, negative 8, you go 4, negative 8 would be somewhere like here. So 4, negative 8. And this is like 2, 4. And what they're asking for is the midpoint right there. And then they want the value of PM. So there's a few ways you can visualize what's happening here. If it's just PM and that is the midpoint, you just want half. So that this question is easier than it looks like. Well, stay with me. This is P what? The whole thing highlighted is Q. That's PQ. But this, what I want here is PM, that half. PM is literally half of PQ. So PM is literally half of PQ. And in vectors, we get to do things like that very, very easy. Half of 2, negative 12 means find half of 2, which is 1, and half of negative 12, which is negative 6. That's PM. What about if they ask you to find the coordinates of M? Find the coordinates of M. There's 2 routes to take in a situation like this. 2 routes to take in a situation like this. We literally want to find what M is. So there's 2 routes you can take. You can literally just take the 2, 4, OP, and add PM to it, and that will be OM. So like if you really understand what's going on in vectors, you'll be able to find the easiest way all the time. If you have a strong spatial understanding of it, and you'll see teachers, maths teachers, show you all different kind of methods, whatever method they feel to do. but sometimes you're not really good in graphs and you can't see what they're talking about. It's like OP, then you go PM, and once you add these two together, that means you would have just found OM. Now, why am I saying OM? Did the question ask us anything about any OM? Yes. The question asks us for the coordinates of M. The coordinates of M is OM. Remember, OM is just the coordinates written in a vertical format. So once you find OM, you find M. I hope I'm not losing too many people here. So I'll give you two nice methods of finding OM. I'll give you two nice methods of finding OM. One is a rearranging of the triangle law, where OM is just another, if I want to say OM, I just need to go another way. OM Yeah, so OM, find the coordinates of M. OM is just go from O. Watch my little diagram. I could go from O to P and then from P to M. O to P, and then P to M. That's the other way. The key to vectors is finding another way. Notice when you're adding, the triangle laws are subtract, but if I'm using this adding technique, there's a little pattern that always happens. This letter and this letter will always be these two, and this letter will be the intermediary point. They will always be the same. So watch out for that little technique if you're adding, if you're finding another way. We'll see it happen again just now. So OP plus PM, we know both of them. We know what OP is. OP is 2, 4. We have that written a few times. 2, 4. And PM, we just find that. That was 1, -6. So the final answer is going to be 3, -2. That's one way to find OM. The key to vectors is another way. So instead of, they wanted me to find OM. So I just went from O to P and P to M, and that's OM. Another way, the longer way, and actually one of the more used ways, is finding the coordinates of OM the old-fashioned way. M is a midpoint. M is the midpoint. How do you find midpoint? X1 plus X2 over 2. Come, why is in the chat if you know about this? You know about this? This is from coordinate geometry. It works. It will work. You get the coordinates of these 2 points, the P and the Q, which we had from before, and you just find the midpoint of the 2. So if you all listen carefully, I'm giving subtle predictions all the time. Somebody asks for predictions. If you listen, I'm giving predictions all the time. 2 plus 4 divided by 2, comma, -8 plus 4 divided by 2. And I will get 2 plus 4 is 6. 6 divided by 2 is 3, -4. So this is -4 over 2, which is 3, -2. So if I want what I wanted, the coordinates of M, find the coordinates of M. So actually this is the answer. This is not the answer. After you find OM, you have to say, therefore, M is 3, -2. That's it. So that's our next little look at some little skills we can do with vectors. Some little skills we can do with vectors. How are you feeling about this class? I think this was pretty good. If you don't understand this, watch this over. This select part a little over a few times. A nice little intro to vectors here, man. So what happens is that vectors don't only use that idea. They don't use that idea, boy. Vectors also use a geometric idea. Boy. Like they can use a shape. Where the most common shape being what? A parallelogram. But who knows? They can bring a triangle. They've brought triangles before as well. And in this scenario, they aren't too concerned about like giving you the coordinates, like this is a coordinate 2, 4, and this is the coordinate -3, 4. They're not too concerned about that, actually. They more will give you a letter. Like this. They will say, this is LMNO, and LM is 2U, and LO is 4V. So sometimes we just have U and V. The easy ones just have UV. And then they'll ask you, what is LM? What's LM in this scenario? Well, LM is just 2u. LM is just 2u. Correct? Okay. What is ON then? Well, see, the thing is, once vectors are the same size and parallel to each other, they're actually the same, you know. What's that? ON, you see where ON is? ON is this, and LM is this. Once vectors are the same size and parallel to each other, they are the same. So it means this is also 2u. Similarly, LO would be 4v. And if I want to say MN will also be 4v. What about if I go from L to N? L to N is what? L to N is what? What is L to N then now, class? L to N, the key to vectors is finding another way. So I don't know L to N. I don't even have a line drawn for that. But I can go up this side, hit them the 2u, then come around the back so. And that's actually a 4v there because it's parallel to this, right? So it's 2u plus 4v. I can write a statement for that too. I can say Ln is Lm, pick back up on M, and go to N. Are we cooking? Is the pot bubbling? So this is 2u plus 4v. Now notice how many of you are able to get that out in the chat. Most people, the highest volume of people so far writing answers easy. What does that tell you? The first part of vectors have a lot of cheap marks in it. Go collect the low-hanging fruit. Don't say just because it's vectors I wouldn't be able to do it. 2u plus 4v. Easy things. The first part, not too bad enough. Go watch any past paper. The first part, not too bad at all. Not too bad at all, ladies and gents. What about if they gave you something like MO? Now, it's important that I have an arrow here. I didn't, but we kind of understood it. MO is what? MO in this situation would be who? Well, the problem with MO, yes, the key to vectors is finding another way. But you'll have to go from M to L. You'll be going against the flow. What we know about when you go backwards, what does that cause? You'll have to go from M to L and then pick back up from L and go to O. So if I write this, I would be writing what? I would be saying to myself, well, I'm trying to go from a M to L, then pick back up from L and go to O. M to L is not 2u, it's negative 2u, plus I'm going in the direction of LO, so that's 4v. So this can be better written as 4v minus 2u, or minus 2u plus 4v. If you understand right, I understand in the chat. I've seen a lot of people have it correct. A lot of people have it correct. So they could come up with all sorts of mischief for this type of question. All kind of mischief them people be coming up with. It ain't easy out there. It ain't easy out there, boy, general boy. Oh God. I'm just not thinking. All kind of mischief they could come up with. Let me see what they came up with this year. So let's just bring up my website and we go and check out this year vectors. Last year, let's check out last year. Maths paper 2 weekend 2025 solutions. Scroll. Anybody could see this website now, right? So you just need to go on CoinSpringer.com and enjoy yourself, my brother. Yeah, tell me if you find any better solutions than this on the entire internet. Go ahead, try. Free. Anyhow, scroll. Vectors is at the ending of the paper, so I don't know why I'm scrolling so slow for. Scroll down to the end, down to the ground. Oh gosh. I think I did this one recently, actually. I did this one recently. Do I want to do this one? Because I did it recently. Yuck. What I was doing earlier back then, boy? Which one was this? 2025 what? 2025. This is 2026 Jan. Yeah, boy. Ugly boy. So let's try the 2025. This is 2025. Let's scroll to the bottom. Vectors, where are they, boy? Oh, I was wrong. I was on 2025. My bad, Ali. Sorry for wasting your time. There are 2,000 people in the live. I didn't mean to do it. Thing. Scroll. Just waste all your two. I know every minute is precious right now. So, all right, let's look at this one. I did the other one recently. I think I did it online recently, right? So, God is love. In the diagram below, OP, let me see if you can pull in some of the vector skills here. You mean to say I can't draw on this, boy? Cool, what is that one, boy? Anyhow, in the diagram below, OPQL is a parallelogram. OP is equal to R, and OL is equal to S. Cool. T is the point such that PQ is equal to QT. You all understand what they're saying there so far? I'm going to take it and kind of break it down. Break it down this. Break it down. Watch it here. Watch it here. I watch it right here. So PQ, QT. PQ is equal to QT. Remember, vectors could be equal and not in the exact same spot. You know? It wants the equal size and direction. PQ is the same as QT. So in other words, it's like two equal pieces. Point M divides in the ratio 2 to 1. It doesn't mean that this is half and this half. It's not even looking like that. 2 to 1 means that I could split this here, here, and here. This is two parts, 1, 2, and this is one part here. So it's in the ratio 2 to 1. Are we cooking? 2 to 1 ratio. 3 parts. So we understand everything on the board so far? Notice how they give me R's and S's instead of U's and V's, but it's the same vibe. R is not the point here. That is rookie mistakes. You can't be making them mistakes day before the exam. They're not good for the baby. So R and the baby is your marks. R and S are not points. They are actually what OP is. OP is R. Look, they said that. And OL is S. We good? I think we good there. So now let's see what the question wants of us. What do you want, kind sir? Find in terms of R and S, PL. Watch. P to L. PL. 3 marks. And everybody could do that. And what is PL? Key to vectors is finding another way. Do you know what PL is? No, you don't. But we could go down known paths. We can say PO plus OL. Come on. Then PO is R. Is PO R? No, it's backwards. Backwards against the flow means negative. Negative R plus, is it going with the flow? It is. So plus S. So this is S minus R. Last hitting like a boss. Put me in the lane. Put me in the middle lane. Come on, man. So SR. S minus R. That's PL. Come, let's go to the next one. S minus R. It's right there. You could go and watch over this online right now, right? Collinearity.com. Where's OM? Are you ready for this? Look, they highlight it here. W solutions. W solutions. OM, boy. OM means I don't know what OM is, but I could triangulate it up there in a kind of form and a fashion and figure out what OM is. Like this. OM is the same as if I go from O to L, then I pick back up on L and I reach M. Come on. And I already know that O to L is S, but L to M I don't know what that is. So I need to pause, stop, think, plan, plot, come up with a L to M kind of vibe. So it stands to reason I need to figure out something for M to L. But vectors work in a nice, beautiful fraction form. And we just figured out what PL is. Stay with me, Ali. And we just figured out that PL is this guy. What ML looking like? How much of it? Now 1/3. 1/3. Yes, man. So ML, careful now, because this is ML, but we want LM, but you know we have a little trick for that later. We're coming back to that. ML is 1/3 of S minus R. It's starting to get fright. You're starting to get frightened now. You're starting to feel your hand beat faster. You're getting flustered. Why? Because you just see this fraction. And you all need to not be afraid of fractions. Why are you afraid of 2 numbers with a dash? It's just the same thing. If this was something, if this had worked out a nice whole number, some people would be good. But some of you all getting frightened for just the fraction. Don't worry about that. I can let your calculator handle that. You just write your thing now, boy. So if this is ML, what do you think LM gonna be in this segue? Because it's LM I really need. Remember I said we're trying to go O to M. Come on, hold everything in your mind. Don't let things spill out. We're trying to go from O to M. So you need to go from O to L and then from L to M. Stay with me, people. Have courage. Be faithful. So you're going from O to L. We have that. That's S. We got that. I have it waiting. But the problem was L to M. We didn't know what it was. But then we have P to L. And then we was like, this is 1/3 of it. So we'll put 1/3. But it's going to be switch the sign. Switch the sign. And how do we switch the sign? Man, just drop a negative right in front of that. Is that allowed? Of course. I wouldn't lead you wrong. So you can drop a negative right there. Negative 1/3 of S minus R. And this is where algebraic skills must come in. Must flow. So this is going to be, see if you can stay with me on this one. S plus and a negative is just a negative. So minus 1/3 times S is what? 1/3 S. Yes? And then minus 1/3 by a negative minus 1/3 R. Yes? Were you able to distribute that? Or would you only be able to distribute things like this? They're the only kind of thing you could distribute. 2x plus 2y. You're seeing that clear. But because I make it a fraction, all of a sudden you wasn't seeing I could just distribute the fraction too. You can distribute the fraction too. Hold on. Hang on there. Hang in there. Just watch out for the signs and the fractions and you're safe. So I just distributed. And then I realized that this is 1 of something minus 1/3 of something. How much you'd end up with? Let me bring out the cake. Let's bring out the cake. If I have 1s and I take away 1/3. I take away 1/3. How many thirds of s's do I have left? I have 2/3 s minus 1/3 r. And that's the answer. This is what makes vectors hard. Not the concept of it. It's the fractions and the negative numbers. And it's good to know. It's good to know because it helps you to plan accordingly. It helps you to plan accordingly. This should be positive, sorry. The double negatives should be positive. Negative 1/3 by negative r is positive. So this should be positive. It's the signs. It's the signs. The signs, boy. The signs is the killer. So what's next? What's next? This is starting to be good. This is starting to be nice. Here's the working. You can get to see how I distributed everything real carefully there. Cool, 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 cool. And then they want you to prove that the points O, M, and T are collinear. So this is the final boss of vectors. So let's go talk about what our collinear even mean. The final boss of vectors is what? Final boss of vectors is collinear. So the final boss of vectors is collinear. So if vectors was a quest, and you had to study vectors like a quest, you have 2 maps that you can play on. 2 maps you can play on. You can play on the map with like the coordinates and things like this. The AB and find vector AB and you get numbers and things like this. Or you can get the map where you have just the geometric shape. And they call this U and this V. And then you have to find P, Q is half U plus V and all these kind of weird things. So you have 2 maps, 2 styles of vectors. Sometimes they blur the 2 together. It's allowed. Just be prepared for if they blur the 2 together a little bit. Then in your quest with vectors, you have to know all your stuff surrounding key. The key for this quest is what? What's the key? Find another way. Find another way. You are going to use this concept in the exam. You don't even need to know the triangle law if you understand this really good. But it helps to know like the triangle law is AB. This is a law that links position vectors to a displacement vector. So that's called the triangle law. This is a good rule in your quest. Triangle law. What else? What else? There's a side quest that is not taught in most schools. A side quest. This is a hidden map. A side quest. Hidden map. Who knows what I'm about to show you here? That is not taught in most schools. We already know that the final boss is collinear. This is the final little thing that I can tell you. And if this comes in the exam, it's usually pretty tough. What is the little side quest thing in school they don't really teach you? It's this: magnitude and unit vectors. Y for yes if you know what I'm talking about, N for no way if you've never seen, you don't even know what to write. What does this even mean? What does this even mean? It's actually, don't jump past this. Don't tune out. Don't turn off your brain. Stay woke. This is real easy points, real easy maths. The magnitude of a vector is based off of like Pythagoras theorem. And all I want you to remember is you want to find the square root of x squared plus y squared. If the vector is in the format AB is equal to x, y, you just want to square this, square root that, and you're going to get the magnitude. Free marks. Free marks that most of the Caribbean don't know. You're beating out more than half the curve just by learning this simple formula. Vectors is one of the most places to get rare marks, rare tokens, rare Pokemons inside here. And the unit vector in the direction of whatever vector is equal, let's say in the direction of AB, is equal to the vector itself, and then you divide it by its magnitude. It's weird, but it's real simple in practice. Very simple in practice. I know I say very simple for some things, but I mean it. When I say very simple for some things, you have to understand it. It really is. I let you know when it's challenging. This is simple. Let me show you an example. Let's say we had A is the coordinate 2, 4. We're coming back to that collinear thing, right? The final boss. We're just doing some side quest in the meanwhile, literally. So this is negative 3, 11, right? Everybody know to find OA? We are just doing that. Everybody know to find OB? We are just doing that. So let's go ahead and find these two real quick. Let's say this is part A, part B. And then let's say part C was supposed to find AB. Boom. And let's say for part D, you're supposed to find the magnitude of AB. Let's go. So OA is simply taking these vectors. Look. OA is simply taking this vector and turning it vertical. Some of you all won't care for that. This is the easiest question in the paper. Please get this question. Please get this question correct. It's the easiest question in the paper. I will say it when I'm doing these solutions, and I might be doing these solutions as early as like 5 o'clock tomorrow and them kind of thing. This math paper has come to me very early, suspiciously early. I'll be said in some of these papers. Suspiciously early. Negative 3, 11. AB is equal to OB minus OA. That's our triangle law. Or you can do the key to vectors another way. So you go from A to O and then O to B. So you just know you need to do the opposite of this. If you're accustomed to that method, that's totally fine. Let me just go across. I like to go down in a line, but I'll go across for space. So this is going to be negative 3, 11 minus 2, 4. Negative 5, 11 minus 4 is 7. Negative 5, 7. AB. So how do you get the magnitude of AB? I just want to tell you all it's a formula. You know? It's a formula. This is in the form XY. So the magnitude of AB is the square root of negative 5 squared plus 7 squared, whatever that may be. Whatever that may be, wherever the chips fall, they fall. So this is the square root of 25 plus 49. 25 plus 49 is how much, Ali? $74. The square root of 74, it have any? Let me see what they say about root 74. I'm just trying to see if it have any hidden surds in that. This calculator not giving me that. No hidden surds. Root 74, 2, 4, 4, can I go into that? 9, 16, no. So no hidden surds in this simplification. So don't put the you could put the decimal if they ask for 8.6. You could put that as approximately 8.6 and it's units. So you have to write units is like a distance you're getting. That's it. And it might go for 2 marks, 1 or 2 marks. 1 or 2 marks and you get that. And then finally, if you want to find the unit vector, this is actually an advanced concept, but you only need to know the easy part of it. The unit vector in the direction AB All you need to do is take AB now. Well, stay with me, because it's going to look real weird what I'm about to do. But it's simple. And trust me, and just do the same thing I do. When in Rome, act like the Romans. Take AB and divide it by the magnitude AB. That's it. What is AB? AB was negative 5.7. Remember, we just worked on that. So we're going to take negative 5.7 and divide it by the root of 74. That's the answer, but it's very ugly. So you want to write it in a neater way. You put negative 5 over root 74 and 7 over root 74. And you are cooking. And you're cooking just like that. Are we cooking? Marks. Marks are the people, boy. Marks. So let's go back to the collinear idea from this past paper. They said to prove a whole bunch of stuff is collinear. They want you to prove that O, M, and T are collinear. What does that mean? What does collinear even mean? Collinear means lies on the same line. The final boss. Collinear means lies on the same line. So if I give you some points, A, B, C, D, E, and I told you these are the points, and F. Now, these are the lines here. If I give you this line, I give you this line, let's pretend E on that line, I give you this line. I can't say A and C are collinear, but that's inconsequential. Any 2 points will always be collinear, 2 points, because you could just connect them. It's when 3 points are collinear is when that's a little more special. Like B, D, and F are collinear, agreed? C, D, and E are collinear, agreed? They lie on the same line. That's what collinear means. And there's a way to show this in vectors. That's what you're showing. How do you even show that in vectors? Well, before you show collinear, you need to show parallel. You need to show that they are parallel. And parallel just means have the same gradient going in the same direction. These two lines are parallel. Now, let's understand a little bit more what makes something parallel. I spoke about it in a recent TikTok video. Okay, I need a grid. Let me just pull out a grid or the hat here. Square paper. Let me show you what makes something collinear, right? Parallel, I mean. If I tell, like, let me zoom in there to youth man, right? Boom. If I tell a red man, hey red man, I red man day. And I tell a red man, start here, walk 2 blocks so, and then walk 3 blocks so. Cool. 1, 2, 1, 2, 3. You see the kind of form red man that they hit there? Or you see them? And if I tell green man now, green man, watch green man. I tell green youth or green girl to walk 1 block so and 1.5 blocks this way. So 1, 1.5. So this is 1 and 1.5 is written as 3 over 2 if you want whole numbers. That's 1.5. This is written as 2, 3. That's the vector. You notice how they're parallel? Why? Why they're parallel? Let's do another guy. Let's bring another guy into the mix. Let's say I have black man. I tell black man to stand up there by blacks. And black man, you need to start here, go across 4 blocks this way, and then go up 6 blocks. He's still parallel. All these vectors different. How they all of them managing to be parallel? He went 4, 6. Why are they parallel? This is what you have to know for CXC. How do you show parallelism? How do you show something is parallel and why is it parallel? Well, it turns out there's a common scalar factor that can be derived from these vectors. This, can you see that this is just twice as big? In fact, I could take this and rest it right here so. As if it's parallel because for this are going across proportionally the same For every one that she's like the unit, you know. For every one that I go across, 1.5. So 1.5. Another one, a half and 1. You understand what I'm saying? So that is what makes something parallel as a vector. That is what we're looking for when you get the parallelism of a vector. You see, the fractions make it really hard to see, but we can see it really good with red man and black man. If red man vector was called AB, and this, black man vector was AB and red man vector was PQ, we can say AB is literally twice as big as PQ. This is what you have to write in the exam a lot of times. AB is 2 times PQ. And you can show you with the numbers. 4, 6 is 2 times 2, 3. Y'all understanding the parallelism? Oh, I get the black man more line than the red man is racism. Focus now. Focus now, boy. So we're going on the green game, like sexism. So, all right, 4, 6, 2, 3. So that's the idea, and it's what happens is that it gets difficult to see what is a fraction. So I'm going to draw a few, and I want to see if you all can spot it. Let's play. Can you spot the parallel, or can you spot the scalar factor more so? Let's say I have 2, 3, and then I give you the vector 8, 12. Are these parallel? And what is the scalar factor if so? What is the scale factor if so? Let's say this is vector, let's just say it's vector P. Sometimes you could call a vector a common letter, Q, instead of saying O or Q or whatever. Are they parallel? Yes, they are. And the scalar factor is 4. We can see that P is 4 times that letter. These two numbers and letters don't do good to each other when you see them. And as a math teacher, yes, I don't know yet. Experiences teaching these things. But let's say now we have M is equal to 5, and this one is equal to 6. And then I say N is equal to, I say this one is equal to, let's make this 8. I want to come across something a little more interesting here. And let's say I get 3 and 2. And I get 2. Is this parallel? What is the scalar factor? Is this parallel? What is the scalar factor? Are they parallel to each other? They actually are. So depending on which way you're looking at it, the scalar factor is either 4 or a quarter. They are. I can guess with this number. I can say 8 all to get to 2, boy. 8 divided by 2, 4. So it's like a divide by 4. So it's like a quarter then. And then I check 6. 6 with multiply by a quarter, 6 over 4. 2 into this 2, 2 into this 3. And that's what a lot of people do. So it was like a quarter, which is fair. That's cool. And they are parallel. They're related by a common scalar factor of a quarter. Or you can say the other way around. I could point this way. I could say M is actually 4 times N. If I multiply 4 by 2, I'll get 8. If I multiply 4 by this, 2 will cancel with the 4. Get 2. 2 times 3 is 6. So M is 4N. I can do the backwards. You understand? Now you're starting to get the eyesight. You're starting to get the eyesight for parallelism. If they are equal, they are parallel. So like if M is 2, 1 and N is 2, 1, well, that's it. They're parallel. Now, that's just parallel. That's just for parallel. How do you explain collinear? Well, collinear is the easiest thing. If I show that 2 vectors are parallel, right? If OA is parallel to AB, like I'm saying that OA is 1, 3, and then AB is 4. Let's not use 4 there again. 3, 9. What's the scalar relationship? What's the scalar relationship here? How do we know they are parallel? Because AB is literally 3 times OA. That means they must be parallel. There's a scalar relationship of 3. It's just 3 times as big. 1 3 would be like this, and 3 9 would be like 3 9. Start there. Hey, fighting myself here, boys. 3 9. Let me start here. 3 9 would be like this. They're still parallel. So here's the thing. Here's why these are actually collinear. These are actually collinear, you know. Not only just parallel. To be collinear, you must be parallel and lie on the same line. And here's how you prove that they are also collinear. How do we know that these points lie on the same line? Well, they're parallel. This is A, this is B, this is O, this is A. Hold up. This is what? A. This is what? A. You mean to say that these things can connect to each other? I'm grabbing my brackets there. I want to not grab the brackets. Yes, these things can connect to each other because both of them are A. Bang, that's where it really is. That means they lie on the same line and are parallel. So how do you prove something is collinear? Class, you just need to prove that they are parallel and that they share a common point. Parallel and run through a common point means collinear. Let's go back to the question. Let me go and collect we marks now. We have all that we need. How are we going to prove that? I'll actually show you right here in the question paper that OM and T are collinear. And we already worked out OM earlier. We already worked out OM in the question before. And we had 1/3 2s plus r. I think we had it like this: 2/3 s plus 1/3 r. Do you remember this? Oh, that was too far gone. We do it right here now. Where is it? 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 2/3 s plus 1/3 r. For those of you who just came in, we went through the whole process. We came up with that. That's OM. Now they want us to show that OM and T are collinear. So what I really need to do is get MT. That's my game, which took a lot of doing. I'm going to just show it. I need to get MT. Because from M to T, it means I have to go down ML, go up LR, and add on QS. You also understand why it's highlighted now? The key to vectors is finding another way. If I want to go from M to T, I have to go down MR, which I know is 1/3 S minus R. Remember, I know that is 1/3 of PL. Stay with me. Watch the fractions. That's what hurts in here right now in vectors, the fractions. If you manage to understand that, okay, I have to deal with fractions, I accept, Lord God, me the serenity to accept the things I cannot change, and you start to work with the fractions, they will begin to work with you as well. So this is 1/3 of S minus R. Remember, this was just S minus R, PL, and ML is 1/3 the way. So you're going to add on that 1/3 S minus R, you're going to add back on this R and this S, and that's what all is working is here. ML plus LQ plus QT is 1/3 S minus R plus S. I multiplied out the 1/3. I distributed. Follow the distribution. 1/3 by S is 1/3 S. 1/3 by negative R is negative 1/3 R. The same way how if this was 3 and these little letters inside here, everybody know you can say 3S and 3R. Well, minus 3R is the same thing with the 1/3. Don't give them fractions, all them power over you to how you feeling fair and thing. You run the fractions the same way. So this is 1/3 S plus S. It looks a little scary, but 1/3 plus 1. 1/3 plus 1 is 4/3. 1/3 plus 1, which is 3/3, is 4/3. You can put it in your calculator too if you're worried about how you'll do it in the exam. 1/3 plus this 1s here is 4/3. So that's why I end up with 4/3 S. And then negative 1/3 plus R, we did this already. If I have 1 and I take away 1/3, I'll end up with 2/3. And that's it. This is 4/3 S plus 2/R. And I can pull out 2/3 from this. So I'm gonna take this part here. This is a really nice question. It's last year, 2025. If you all want to get something to really challenge you with understanding collinear and how to work with fractions, this is the paper for you. So this is the vector O MT. This is the vector MT, the last line there. And then we already have the vector, what was it? ML or M or OM. OM. What was the vector OM from before? These two lines here. And the question is asking us, are these, or show that they are collinear. You remember what I said to show collinearity? How do you show collinearity? So even if you ended up here and you couldn't see your way further down, how are you spotting that scalar factor? How are you spotting the scale factor there? See what I told you about the fractions and spotting the scale factor? They're parallel, you know. 2/3 R, 1/3 R. Can you see that this is just 2 times? If I'm going this way, I multiply everything here by 2 and I get that 1 by 2, 2 by 2. Which means that MT is just 2 times OM. That means they're parallel. That's the mark. That is the mark in the exam. More people should be conquering this question. I mean the entire question. Everybody should be conquering at least half of vectors. But more people could actually do better in vectors if they put their mind to it. If they accept that you're going to deal with fractions and negative numbers, and that is what really ties you up. Be honest with yourself. Maths is about honesty. So MT is equal to 2 OM. So that means they're parallel. And are they sharing a common point? Yes. Both of them are going through M. You can see it in the diagram as well. This is, I need to snap the diagram to bring it on. But can you see it? OM and MT? Can you see it? OM, that's OM, and this is MT. What we just found is that MT is actually 2 times OM. And they share the common point M, so that means they are collinear. So that's what I will literally write for the answer to collect the marks. So you'd write, since OM is a half of this and this, we can say that 2 OM is 1 MT. This part here, 2 of OM is 1 MT. Therefore, they are parallel with a scale factor of 2. And since they share the common point M, they lie on the same line. OM and T are collinear. That's vectors for you, ladies and gentlemen. Let's see what's next on our revision plate. Everybody press like on the stream. Let's go get some more points. Construction. How about we take some time and do some construction? Construction. Everybody ready? Take out your set. Take out your geometry set. Let's go. Let's take some time and run through some construction. Construction time. Construction time. Are you ready for construction time? Let's look at back in the days when construction was premium. Construction was sharing cheap. Okay. I thought I was fine in construction day, but I'm looking bad out here. But let's start from 2018. 2018 is when the syllabus changed. Right, boom. You want to construct this. So you're going to do this. Everybody, try to do this fella here. Try to do this fella here, right here. Actually, let's see if I bring up the scribbler and I do it on the scribbler instead. New page. Always do this again. I forgot. Bang. And we want blank. Boom. So we're trying to do this. Let's go, folks. Using a ruler and a pair of compasses. Is that my max zoom? Let me just refresh this, please. Using a ruler and a pair of compasses. And again, these zoom to zoom. Construct this. Let me see if I can make this a little bigger for you guys then. So go ahead. Y'all can do this. I'll be back in, how much time passed? 1 hour? Back in 5 minutes. So you're taking a 5-minute breather here. But do this in the meantime. All right, we're back. How much people we lose? We lose about 100 people. I wanted to bring on a student, so I'm trying to see if I could get them to come in. And I know sometimes it's useful to see like a little feedback, a little bounce back as we talk to persons. So let's see if I could get them in. All right. Are you done? So here's how we do it. Everybody lock in. The first thing you want to do, and if they ever give you a sketch, they haven't been given many, but they're still there, is get the sketch of it done first, like a quick sketch. You do 8 centimeters AB, then what? BAC. BAC is 30, so we kind of draw the 30. You kind of plot out a 30 in your mind, how we do that. So that's 30. And then AC is 10. A to C is 10. So it'll be a little longer, maybe out here, so 10. And then you do so. And then you read down to see if it have any other parts in the question that would require you to like maybe make up an additional addition to this shape. So if you need to do that, you know how much space you have. So now you have an idea of what you're going to draw. Everybody understand what I'm saying? Always make a quick sketch of like how it's going to, trust me, that's important. Those who doing technical drawing, you know what I'm talking about. You need to make a quick sketch. You kind of vibes it and see what's going to happen. Now, what we'll have to construct a 30, and we know to construct a 30 degrees. Yes, it's like bisecting a 60 degrees, and we know to construct a 60. All right, let's go get this bread. So first things first, we need a ruler, and I mean, we can literally just draw 8 centimeters. My paper kind of small here. You could literally just draw 8 centimeters. But in construction, what we do is actually we go more forward and backwards, and we use our compass to kind of like construct the idea. Let me show you what I mean. The idea of the 8. So like you put a little dash here on where you want to start. Then what you're supposed to do is open out your compass. So you go on the 8, the dash mark, and open out your compass to 8. Now 8 is what on this compass? 8 is, see, a line up 0, and 8 is there. If you know, you know. Bang. So that's your 8. Then you make your curve there. Why isn't the chat if we cooking so far? So that's your 8. That's where the 8 is going to come. It doesn't need to be such a big line, to be honest. You just make a little dash like that is good enough. So that's our 8 from the first one. Then you need to make 30 degrees. So 30 degrees is done like this. The first thing I want to do, get a nice length. I'll lock my compass there. You don't need to lock it. You just need to hold it there. You make your line that goes around like this. And you come on this spot here now. X marks the spot. And you make a line that's coming back. That, if you connect from here to there, that is actually your 60 degrees. You don't need to draw it. It's not necessary, but most people do draw it. So you make a 60 degrees. That's a 60 degrees. So if I wanted a 60-degree triangle, that's what would have been happening. Yes, class? Yes, sir. And then you want to bisect the angle. So to bisect an angle, and I'll show you how to bisect an angle again just now. You come here, and you know just about half so. I want to lock it because after it's done, it's done. I need to come and do it on the next side. Make an arc, and then come on this side and make another arc. That's how you bisect your 60. What you're going to do is just now connect this line. You're using your ruler, you connect that line, and you go straight through the area that you bisected. Bang. And what's the last step? 10. You need an next 10. Are we seeing that, class? Why isn't each other you feel you're catching the gist of what's happening here? We need the 10. We needing a 10 right there, so. So once again, you could use your compass to kind of show like you was, or pretend like you use your compass to like draw the dash there. Same thing like what I did down here. But I'm just drawing it in right now. And that's you. That is you right there. You just did what you're supposed to do. Connect this up there. Well, look at the idea. It's a little too thick. It's too thick. The lines that I had before are what we call construction lines. So that is not like the serious lines, but the examiner wants to see the construction lines to know if you're doing the right thing. And you join these up. These are your darker lines, and that's your triangle. How are we looking, people? Bird. Bird. This is one of the easiest things on the paper. Hey. Kalimi on the inside. That's now, let me make sure this man looking like he have one. This man bareback and trying to come in my life here. Let me see how going on. Yeah, but I have vest. All right,
yeah, vest.
All right, you remember this? You remember how to do this?
We sir. Like angles and things. Construction.
This is construction. This is construction, bro. Construction. So let's do our next one. I'm going to do one from scratch. Let's say I have to construct a triangle that's 5 centimeters this way, 60 degrees this way, and maybe 8 centimeters this way. Everybody start it up. See if you can do this. You remember how to construct the 60?
So I ain't gonna lie, I'll in the algebra better. You see here, I forget the construction. I ain't gonna lie to you.
So you jump in some algebra afterwards?
Yeah, I'll jump in the algebra. But I'll watch the first question, no? And try.
All right. So let's go. So if we have to do 5, I'm just gonna do it how I would do it if I were you all in the exam, right? So I would actually just take out my 2H pencil. That's the light pencil. If you don't have one and you have a HB, that's okay. Just use the HB pencil and press light. And then when you're doing the final thing, you press hard with it. I've done that for maths. So you press light with this and you press hard for the final diagrams. So that's called the construction lines. You just give them a little line on the bottom there. Cool, boom. But we really only want 5. So I will just make a little dash here on the 0 and a dash here on the 5. Notice how it's over. It's okay. It's totally allowed. It's expected to overshoot. So this is the real 5. And my plan is in the end to come and darken this. Y'all understand? That is where it's getting that little perfect engineering, technical drawing thing. Where's this boy? What's the leave number?
Yo, chill. Listen, guys, I'm a man of the Lord. I focus on, business right now.
And I know this, Khalid. I don't know what's wrong with them. So therefore, we need to construct the 60 here. So I'm gonna do so. Make a line right there. We just do a 60 actually, but we bisected it. This time again to keep it. Plop he down right there, so bisect that. That's a 60. When I connect this up, that's gonna be 60. When I connect it from this end, everybody understand how you're cooking?
Right.
So that's a 60. And you notice how I offshoot it again. I just go and it didn't stop at 8. I'm not trying to get it perfect the first time. I'll darken it. They want to see my construction lines. And then if I were you all, I just use the ruler now to measure off this last bit here. You know? So I just use the ruler. What is the
8 centimeters now.
Yeah, the 8 centimeters now. And yeah, come in here. And you just kind of measure off the 8. Bang. Really, what you're really supposed to do, especially if you're in technical drawing, is use your compass and measure the 8 and show that it cut there. So like I just do a little dash for kicks. Just, a little dash here. Nobody has to know. How will they know? and then you darken. Kick. So let's pretend this was a little thicker. So that is you there. Ladies and gents. And you would have just constructed a next triangle. How are we looking, class? Only one next one, or it's time to move on to something that this man can do?
Yeah, read. I feel like that's simple.
Yeah, that's simple. And what you want to do is label it up. So like if they said A, B, C, you make sure and label. A, people saying one more. A, B, C, and them the 60 degrees, 8 cm and your 5 cm. So let's just do some quick little skills on it that you see me doing. Some of the skills you saw me doing was bisecting, but I didn't show you how to bisect a line. So like if you have a line, I did this actually some time ago, and they want you to bisect the line, a perpendicular bisector. Let's say you have this line and it's a random line, and they want you to draw the perpendicular bisector of the line to meet this line. Something like that came at a farm or something sometime, right? So this is the point A, this is the point B, this is the point C. They want you to draw the perpendicular bisector of C that will meet this line somewhere. So what is a perpendicular bisector? What is a bisector? It's the same thing really, you know. When you bisect the line, it turns out to be perpendicular, the type of construction you do. So what you want to do is open this to a little more than half the line. Bang. Come on this side. It didn't look like I do it right. Yeah, I did. Bang. And that's your bisector there. That's you right there. And you draw this line straight down. Ringing a bell, everybody. Colleen, how the song familiar?
Yeah.
So the green line is what we call the perpendicular bisector. And you would have bisected the line into two parts here. This line is now split into two parts. How do you bisect an angle? How do you bisect an angle? So Kaleem is a past student. He also did some videos with us back in the days. So when you write CXE, Kaleem, what year that was?
2020.
Oh, the cursed.
The cursed, yeah.
2020. 2020 was probably the most eventful year in terms of writing.
Exactly.
What are the worst years? So in case you missed it, I just made an arc like this. I just made an arc like this around there. Then I'm coming on this spot. And I can use the same length, or I can make it a little smaller just to get a little, but then I'll have to like lock it back again. Bang. And I'm coming on this spot. I must keep the same length now. Bang. And that's how you bisect an angle. So whatever that angle was, the red line is now cutting halfway through it. So that's bisecting an angle. Are we cooking? Think we're cooking? So let's say they wanted you to do this type of triangle now. Because I feel like construction may show up. It's a kind of 50-50. So I don't want to spend too much time on this. It's not guaranteed. Let's say they want you to make 6 centimeters here, right angle there, and they've never really brought 75. It's kind of weird for 75. These comments killing me, I know. Let's say I have 60. Let's say I have 60 here. I have 60 degrees here. So I have 90, 60, and 60. I bring a past student on to help all you feel the vibe and the energy. And look what you're writing in the chat. All you
So
put on your best behavior. You're not seeing it? Good. It's a good thing you're not seeing it. I don't want you to get distracted too.
Alright.
So you're not even seeing it. So what you want to do is take your compass, take your ruler out. Be on your best behavior now, man. This reminds me the back in the days when you bring in a past student in the class and everybody in the class, you know. The past student come to check the teacher. 6. So I'm gonna do the same trick again. I'm gonna go longer than I really want to go. Then I'll put a dash on the 0, a dash on the 6. And I want to construct a 90 degrees. So if you want to construct a 90 degrees from a corner, there's a way to do it. Let me show you. You put your compass on the center. Then you draw a line like this. Find this a little too thick. Let me draw a line like this. Now you're gonna need the line to go a little further this time, like maybe about down there. So then you come right here. Draw a next line. What is this angle? We do this like 3 times already. Where's the angle, Khalid? So if I do this,
that look like a 60.
That's a 60. So now if I take the compass and I go from where this 60 is, it must be the same length, right?
Right.
And I draw it again what I would have done is make a next 60, 60 and 60 is how much?
120.
120. So that's a 120. So if I wanted to do a 120, that's how you do it. But they don't want a 120. They actually want the thing that's between a 60 and a 120, which is what?
That would be the 90 kind of thing.
That would be the 90. So that's why you're cooking. That's why I will come now and draw back this 60, this 120, and bring it all the way up there. Because I'm going to bisect it one time and come back where this is and slice there. So what you all need to do is come back and watch this in slow motion. But I want to show you a trick with this, because look how off I am. Because this thing not grabbing the center where I want. So a trick I do with this is take my set square, telling you, take a set square, line up the 90, and draw it one time now, boy. So draw the 90 one time using your set square. So I'm drawing the 90 one time. That way, as I constructing this, I will kind of gauge it. I'll catch where I'm coming from. That's called ratchet, by the way. So I'll kind of gauge it. So that when I come here now, I know what my target is. My target is about there, so bang. All of a sudden, your construction's looking perfect. Perfect. I'm showing all the inner secret Jedi tricks here now. So now, all you want is, what just happened here, boy? All you want is 6 centimeters. This way, which you already have. So we just need to construct a 60 from that side and we cook in. So here's how we do that. We come here now. You can use your protractor, measure all the 60, and then construct the 62. Same way. So you know that you know. That's 60. When you come here, cross that line, and when you cut through this, going up the road, that's your 60 degrees. And all you need to do is darken that triangle now, and you would have done it.
So, question though, like, I know the syllabus kind of maybe different, from back then. Like, where's the subjects or topics they're more focused on the CX?
Hold on. I need to make sure it's not echoing. Guys, it's echoing? Because it's normally echo when I have somebody on. Let me see if I get my headphones. Let me get my headphones. I'm coming back.
Yeah, guys, I'm very much sorry for the echoing, guys. I will speak a bit softer. It's not my fault. Technical difficulties. By the way, welcome. I hope all is studying. Tomorrow is maths. So make sure and do all your work. We want educated young youths coming out in the future. You understand? If you're from Guyana, big up you. If you're from Barbados, or you go race and next in your backside there, big up you. If you're from St. Lucia, big up you. If you're from Trinidad, big up you. Wherever you're from in the Caribbean and you're right in CSEC, all you will do good. Just lock in.
Alright, Kelly, I've seen all your comments. Alright, you hear me now?
Yeah, I hear you, sir.
Alright, so what you ask me? The topics or something?
Right, yeah, the topics and stuff like that. I know matrices coming for sure. Circle theorem supposed to come.
So now is a good time. I was promising them to do that. So topics. People, these are the topics that are coming. So the plan is, let's look at the plan from a macro first, the big plan, the master plan. We had to jump back into it, guys. It's not like we have time to talk about this too long. The plan is that we have paper 1, paper 2, and paper 3. Paper 3, most of y'all here would have done the SBA. Some wouldn't. Some would have done the paper 3 that passed recently for 20%. So anyway, take it, everybody here done with this. You can't fix that now. That dead. So hopefully you get good marks in that, right? 20% of your final mark. The paper 2 is what we have tomorrow. How much percent this is? 50% of your final mark. Half of your final mark. It worth 100 marks. So we had to give this our best shot. Our best shot out of them 100 marks. Each mark is 0.5%. This was actually with 20 marks. So each mark is actually 1%. And then the paper 1 is coming up later. Next month, I think they split the paper 1 and paper 2 from back in your days. Kalim, you just do the paper 1 because they throw the paper 2. But so the paper 2. The paper 2, what's going to say? Well, the paper 1 is 30% of the final grade. So the paper 1 is coming later. That's what I'm going to say. They had split it. So instead of having it on the same day, like I think you did, well, you were supposed to do both on the same day, June is when they're going to do paper one. When
I
is
did
paper
it in
one, everybody?
John exams, I wrote maths, English, and physics. So I wrote paper two as well.
Yeah. So you know about that, right? So it used to be on the same day, but now it's not. So this is 30% of the final mark, and this is 60 marks. So 60 questions, 1 mark each. Each mark is 0.5%. So the plan is that you really have to try and do the best you could here. When we reach paper one, we'll be back for a paper one session. I have 500 of the questions that is best to practice for CXC Maths that you all need to practice. It's on my website right now. Right now, if you go on my website, on the bank, where is it? CSEC Maths, back to papers, maths. You click on this. How much questions we have here? Endless. 513. So these are all the possible questions.
So you upgrade by
so
you
yeah,
upgrade online thing like that.
Yeah, so they could go through the questions here and see.
So
and
you get Khan Academy in the Caribbean.
You can get to see. Yeah, I tell you, this is real good. This real good. Some of y'all know these questions, and if those of y'all who've been studying. But we're not time for that. No, we can put on the back burner. We can come back to that. So paper 2. How is paper 2 separated? Well, there are 10 questions. 10 questions. And you have to kind of plan fit. 10 questions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'd have touched every single question in my class, of course. Question 1 is your computation and numeration and your consumer arithmetic. I'm not doing any of that today. I have enough of that on YouTube. Algebra is question 2. I wasn't planning on doing much of that, but I'll do some. Do some algebra. I'll do some, what I want to do is algebraic fractions. So we're coming up to that just now. So you must get these 2 marks here. Kalim is a past student earlier. And question 3 is geometry. So the geometry is normally like construction geometry or transformation geometry. So you're not going to do some trans here, pause, some transformation here, or you're going to do some construction here, right? And transformation or construction. And you can also get some coordinates and stuff like that, little, but something in geometry or some trigs, some minor trigs shows up here sometimes. Question 5 is stats. Question 6 is measurement. So question 4 is usually functions. That is the f of x thing and the g of x and the f inverse of x. You remember that? You still doing that in university, Kalim?
So most of us, we just do Laplace and thing, and so we need more algebra. Like I ain't gonna lie to you, that's the kind of math we using.
Yeah. So Laplace is headache.
And stuff like that.
Series and sequences. Well, question 7 is baby series and sequences. So this is something I want to touch again tonight because it's so important to collect this maths. Question 8, we did most of question 8 today. Question 8 is like completing the square. The square. Yeah, graphs, that's quadratic equation. Motion graphs, that is linear programming. Question 9 is the famous circle geometry. Remember that? That's the thing you need to revise the most for. Circle geometry and bearings. So bearings or some form of advanced trigs. And this is vectors and matrices. So we actually really prepared for vectors and matrices in this last crash course. We did a whole bunch of matrices, all of matrices, and we did all of vectors. So this is something we locked off in this last day. We would have done some transformation as well and construction. So we did this. What else we would have done? Question 8, we'd have done some question 8. We would have done a touch of bearings as well. Today, we did that. We didn't do any of these measurement or stats. We did most of functions, all of functions really. So even in this last little crash course here, today, we would have done a lot already. So next on the agenda, you could remind me what's next on the agenda as we pop into it. Let me see if there's anything to deal with algebra. I want to do series and sequences, that's coming. I want to do stats and circle theorem, that's coming. So let's squeeze in some algebra before we jump to those things. Some algebra. And some trickish algebra. Anything to do with making something, we're going to do circle terms just now. Anything to do with making something into one. A lot of people want to do circle terms. So Kalim, do you remember how to get this into one? They say express as a single fraction. These guys may see that tomorrow.
Yeah. So what you'll have to do is multiply the 2 and the 3, so it'll be over 6. That's why I would have do to make it into 1.
Right.
You know?
And then what next?
And then you would you'll have to multiply the 3 on that side. So 2 by 3 would be 6, and then you have to multiply the x plus 2 by 2. So that would be 2, in that bracket, and then you could think it.
It's by 3 actually.
Oh,
so this
shit,
will be 3x plus 6, and this will be plus 2x.
Right.
So this technique is done a lot. So like if I have 1 over 2 plus 2 over 3, from primary school we learn to find, this is called your LCM or your LCD, lowest common denominator, and it'll be like 2 into 6, 3, and you multiply this by 3, it ring in a bell, 3 into 6, 3 into 6, 2, and you get 4. Get it? So then this is 7 over 6. And then you can change this to 1 and 1, 6. Now this is 5x plus 6 over 6. Now this could come a bunch of ways. So Kalim, you will be the person to tell me if it's easy or hard. Let's see what's going on here. Let's say I have x over 3 plus 2x over 5. Can you do that? That's question 1. Everybody. Kalim, if you have pen and paper, you can start now. Eh?
Yeah, I can. Let me really get
see if you can handle that. So you have 2x plus 3. I bring this man here to do some work. Plus x minus 1 over... I want to make this one 10 though. Let's see if you can get these two. Let's see if you can get these two.
Well, I'm a pen and thing ready.
That's baby thing. All right, Candace say the baby thing.
Yeah, that really.
This year. 15. And she have it right too. Yes, you're going to put 15 on the bottom here. And then it'll be 3 into 15, 5. So you get 5x there. Kalim, stick it. 5 into 15, 3.
6x.
6x. So you end up with 6x there. And 5x and 6x is 11x over 15. Just ring a bell. Is that question? Yeah. So what's the LCM for this one though?
Moving fast.
2. What will be the LCM for this one? Don't just put 50 here, because you might say multiply it, but no.
Yeah.
You could just put 10.
10, yeah.
Because 5 could go into 10, so you put 10. And 5 could go into 10 2 times, so you'll end up multiplying this by 2. So you'll get 2 by that is 4x plus 6. 10 could go into this 2 times, so you'll end up with 2 by x minus 1. So you'll get 4x plus 6 plus 2x minus 2. Class, are we cooking? All over the 10. And in the end, you'll end up with 4x plus 2x is?
6x.
Sorry, wait, I have a mistake.
It's supposed to be 5x, if I'm not mistaken.
Yeah. I don't need to multiply this by 2 at all. I just need the x minus 1. Because this is 10 already. 10 into 10 is 1. So you just put, so you get 5x, and what?
And that will be minus 5?
No, plus 5. 6 minus 1 is 5. Plus over 10. Right. And this one could reduce, strange enough. You can actually reduce this. 5 could come out of everything. Yeah. This could actually reduce to x plus 1 over 2. 5 into this 2. 5 into this 1. 5 into this 1. So since 5 could come out of everything, you could reduce it. Class, are we cooking? We getting real people inside here, boy. 2,600. Let's go again. Another one. So yeah, my food almost went. So we're gonna increase the difficulty. No, I forget what number we're on. We pretend our number 4 and 5 here. Let's say I have 4x over x plus 3 over 5, and I want that in one fraction. How do you do that one? Notice the denominator has the x in it. What about if I have x plus I hear some noise in the background. What we done? Plus let's put x plus 1. I think this is the worst that ever came. Let's see if you guys are ready for like this scenario.
So for 4 I get 20x plus 3 over 5.
Alright, let's see. So x plus 5, the LCM you must multiply. If you see a variable and a constant like this, you just multiply. So you get 5x or x by 5 was better.
Five.
It's not, yeah, just put 5x. You don't put x5 there like a BMW or some kind of thing. Put 5x, right? So x into 5x is 5, so you multiply this by 5, and you end up with 20x.
20x. Yeah. I get that
And
one.
5 into 5x is just 1. Well, it's actually is x. 5 into 5x is x, so you end up with 3x here. Because this will multiply by x. Yeah, that is the part you miss. So you'll end up with 23x over 5x.
Alright.
So just now, let me make sure.
So let's just refresh. That's for me, you know. Don't worry, I'll catch you back. Don't worry, I'll catch you back.
X into 5x is 5. 5 by this is 20x. 5 into 5x is x. So you get 3x here. So something weird happening here, boy. The x's cancelling. Actually ended up with 23 over 5. That's very weird. This don't usually happen. 5 into 5x is x. X into this is 5. Yeah. So that's a little weirdness that happened there. But this one.
Alright, let me see that one.
But most of these chat got up to here, so big up the chat.
So the cooking, I don't know, I don't see anything. So the cooking,
the chat is cooking, and the chat is cooking you. They're saying I'm not supposed to be teaching you. I'm supposed to be teaching them. But I'm using you as like the pivot for them.
Yeah, don't worry, guys. It's been how much I do CXC in a long time, so don't worry, guys. All they gonna be like that when all they finish. Alright, this one.
Wait. So x by x plus 1, and that's what you all should have in the denominator, which can we go to x squared plus x. When you multiply this, you get x squared plus x. And then it'll be x into x by x plus 1. You get x plus 1 multiplying here, so you get 3 by x plus 1. So that's what you're supposed to be having so far. And x plus 1 into this is x. You notice how when I send this down into this one pop up? That is scale there. Boy, it's not in between. Is either they cooking you or they over glazing you right now?
The glazing, I say what the glazing for?
Some glazing you. Some are like, take Kalim off now. Some are like, Kalim distracting me, sir. Thing.
By barely talking, how am I distracting them?
And then you have 3x plus 3. 3x plus 3. Plus 2x. Yes. And then you have the x by x plus 1. And this one tough. So you'll end up with 5x plus 3 over x by x plus 1. You only want me to go and hunt for some? Let me go and hunt for some in the past papers right here, right? So, bro, my website on fire these days. Yeah. If you're anybody doing maths, let them know to like this selfie, right? So, let's go check from 2020. Come on, 20 Jan. Let me see. This man do this paper actually. This is your paper, Kalim. They start off with these factorizing stuff. Blah, 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 blah. Nah. That's not what we want. 2021. Maybe we should learn factorizing and that so we'd have more things to pick from. Nah, that's not what we want. 2021 again. Did I click this just now? Yes. So this has a little bit of it. This is a tier class. This has a little bit of that idea. We need to show that. They actually give us the show that question here. So see if you all can do this one. It's the same idea. That's now I'm trying to get it to be able to piece. So it's the same idea. You want to get these two things and merge it into one. How are we doing that? They actually told you what the answer should look like. This is what they mean when they say show that. That's the answer. Show how this will get to look like that. Kalim, you feel you can do that one?
All right,
the name of the website is kerwinspringer.com. For those who want to know.
Yeah, go and check out kerwinspringer.com and go and do all your maths. Remember, all your maths tomorrow, not me. So make sure and do all your maths. Let me see if I can do that.
Right now the comments. I might have to pause his comments right now. So
that
yeah,
is
how we
also.
right now them spazzing out in the comments right now. So x over 1 minus x minus 4x. X over 1 minus x minus 4x.
Let me see if you could just show that. So you'll have to bring that over.
Hint. For those of Samantha, you supposed to know how to do this, eh? Colleen, don't tell the chat anything wrong right now because they will light you up, bro. And I can't protect you from them. I can barely protect myself. So x over 1 minus x minus 4x over 1. That's a hint there. So it's the same idea. It's just that we have the denominators. One of the denominators is 1. So, hint, look at this denominator. You know, this is always just 1 minus x. Because if I multiply 1 minus x by 1, I'll just get 1 minus x. I could put the 1 here, but I'm not changing the price of milk. Just remember this, people. Remember this. Watch this flow, right? If I have x and y here, the LCM is x by y. You multiply these two. And when you go down into this, you'll come back up with the y. So the y will go by the a. When you go down into this, you'll come back up with the x. So the x will go by the b. You can put bx if you want. That help? Let me show you what I mean with numbers. Like if I have x over 2 plus, let me put the numbers on top. 2 over x plus 3 over y. Below we'll get xy. X into xy is y. The y will come up and multiply by the 2. Y into xy is x. Chat, you all understanding that? More people on board the train? More people come on the bus? So this gave me the 1. I could put the 1 if it will help. This is like the x and the y. 1 into this. I will come back up with the 1 minus x. I'll get 4x by the 1 minus x. And when I do 1 minus x into this, I'll come back up with the 1, which is not going to do anything. I just have 1 by x equals x. And that's what they're looking for. That's what they're looking for. So x minus 4x minus 4x by minus x is minus 4x squared. And x minus 4x is something, by the way, and this is just 1 minus x. So we're real close to the answer now. X minus 4x is minus 3x minus 4x squared. This has to be one of the hardest ones. Like math students will cook this, but
so I get the answer, but I ain't gonna say nothing. Next thing I get cooked for you. Yeah, I get the answer, but I ain't
you get it? Yeah. So you need to pull out the x out of this. Actually, you pull out a negative x, because you pull out negative x into 4x minus 3. X from this is minus 3 and x from this is minus 4x. But I took out negative so you could switch around like this. Over, and I have, why had I had 1 minus x, so x minus 1. Let me just make sure. Oh, this was positive, so I didn't need to pull it out negative. Yeah, it just come out like this. Yeah, it was just positive. Yeah, well done, Kalim. You're showing the answer? Yeah. So this was a rough one. This was a rough one, boy. But I just tried to show you all that somebody said it's a baby. This is actually a pretty tough topic. It can come pretty tough. You all want a next one like this? You all want a next one like this? Let me see if I can produce a next one like this. Let's say I have x plus 1 over, let's put a 4 there, and let's put plus 3x. And let's say I want to make this into 1. Make it into one fraction. Make it into one fraction. Write it, class. Let's go, let's go, let's go. We're going to go through this.
So, back in we days, when we used to see these kind of questions, when we used to watch here, we used to say, yo, cutting grass ain't too bad, and us. Make a like this kind of question. We say, best we're going to be a carpenter or something. Some people
saying, so this is too easy, and some people saying, They're just too hard. They just better bring the circle terms. So what we're saying is that put this over 1. If you're trying to make it into one fraction, put this over 1. If you don't see any denominator, just put it over 1. So I can rewrite this as x plus 1 by 1. If you want to put the 1 here to make yourself feel good, that's fine. So you could go down with the x plus 1 and come up with the 1. So this will multiply by 1, so you'll get 4. It's not going to do anything. When this go 1 into this, you'll come up with the x plus 1. So you'll get 3x by x plus 1. Yes? Any questions about that movement? I know some people have it and some people don't have it. It's one of those things. I can do an easier one with straight numbers to help you see what's happening here. If I have 4 and 10 plus, let's say I have 3, and I'm trying to make this into 1. I will put everybody over 10 and just put back the 4 over 10. But this is over 1. 1 could go into 10 times. 1 will go into 10 times. So I get 3 times 10. So this will be 30. You all know about this? This is primary school stuff. So this is 34 over 10. I don't mean to be patronizing. This is 3 times 10, so 30 plus 4 is 34 over 10. Ask your brother or sister who just write primary school exams. They was cooking on this. It's the same vibe happening here. The 1 went down, and instead of coming up with the 10, it came up with the x plus 1. This one, when the 1 went down, it came up with the 10. Same vibe. It's just numbers.
Smelling a quadratic, sir.
Yes. All right. Yeah, that's cool. So you get 3x by x is 3x squared here again, a quadratic. Yeah, plus 3x by x is 3x. And x plus 1 by x is just x plus 1. So that's the answer. You can rearrange it to be better. Some people already fall behind, like this.
3x squared plus 3x plus 4 over x plus 1.
Yes.
I got that.
Circle using AI. 100% sure Kalim not using AI.
That's I don't know what call it. Don't worry. The hating on my way. A black man could never have it easy.
Kalim, I gave you 15 more minutes, boy. I gave you 15 more minutes, and then we had a pump. Yeah, so the people them want circle terms. So let's jump into this circle term that we have here one time. Let's swing down to this circle term. As a man of the people at the end of the day, and if the people starting to revolt for circle terms, we gotta give one circle term. Let's go. Let's go. Terry did this circle term earlier. Somebody saying let Colleen teach you. Terry did this. Well, if Terry did this, I did unlock that already. So let me pull out our next circle term. You remember Terry, David?
Theorem, so I ain't gonna lie to you. I forget all the circle terms. I write my CXC and I make sure I learn that at the time I CXC, but to say I remember it, I'll refresh that.
Circle terms is one of the things you had to pay the most amount of work to learn.
Yeah. I make sure I learn vectors and matrices and circle term. That was what I did for the 2 questions in part 2.
All right, so let's go. I feel like I did this recently in class. Angle PON. We want to learn angle PON. Angle PON. Let's go. All right, well, let's just pull off this one real fast, and then I will start to give you some. Kalim, your day is numbered, but you're distracting them too much. Your day is numbered. PON.
Sorry for distracting all you. Don't worry. All you will do good tomorrow. All you make sure and do the work and all you would, get ones and then. So you had to remake a song.
Oh, that way. I don't know if I had the time and energy to make a song again, but if I want to see some things, I could go back and watch a song. So this is a triangle. I used to make songs and things back in them days, exam songs. Just type in Kerwin Springer song. So this is 24, This is a right angle because it's a tangent and a normal. So therefore, this angle must be 66. And I see everybody cooking up that 66 already. Language class, language. So this is PON is 66 degrees. And PLM, plum. What is plum? PLM. It's sounding like it's a plane landing in your background continuously, bro.
Alright, let me fix that.
PLM. PLM is 33. Very good. A lot of people getting that. Why is it 33 though? Angles at the center is twice the angles at the circumference.
Better, sir?
Yeah. So angles at the center is twice the angles at the circumference. So if this is 66, this must be 33. Good, good, good. So let's watch the solutions. Those who want to know where to get the solutions, Springer.com, go on like yourself, solutions, all the recent past papers. The angle made by the tangent PN and radius OP is 90, so you write that, and then 24 plus 90 from the 180, and you get 66. Angle at the center of the circle, POM, is twice the angle at the circumference, PLM, subtended from the same chord. So PLM is equal to half of that, half of 66 is 33, and what's the next one? That's it. PMN, PMN. PMN. How do we get this angle now? This is a very interesting angle, actually. How do we get PMN? So there are a few ways to get PMN. There's one critical way that I'm seeing. There's one critical way to get PMN. So you're going to do some fundamental circle geometry ideas, then we have to do statistics. So it's very you think you can figure out a way to get PMN, Kalim? You know,
I just learned right now. I want you know the first question.
All right. Well, to get PMN, you actually need these two lines to be equal. And all of a sudden, I think a lot of people can figure out PMN there. Those two lines are equal because they are radii. So knowing that this is an isosceles triangle, if this is 66, 180 minus 66 is 114. And this 114 needs to split both ways. So it means that this is 57 and this is 57. Suddenly, we can figure out what this angle is. 180 minus 57 is 123. So you had to know this this is actually a pretty useful rule that they use all the time. Two radii would always make an isosceles triangle, and the base angles in an isosceles triangle are equal. It's very useful, very useful. It's not rare at all. It comes regularly in the circle theorem question. So here's how you write that. OP and OM are equal since they are the same radii of the same circle. Triangle OPM is an isosceles triangle. So PMO is 180 minus 66 over 2, 114 over 2, 57. PMN is 180 minus 57, which is 123, since angles in a straight line. Notice how I keep putting the rules. Keep putting the rules of what I'm doing. So let's run through the circle theorems real fast. Kalim, we got link, bro.
Yes, sir. Take it easy on me. Say what you'll do well.
We got link. So let's say goodbye to Kalim. All the people who looking for wait. Kalim, go on, yes. Kalim is going and give you your the website. If you want to see Kalim, where's this man website, boy? I know he on TikTok or something. For the people who want to follow Kalim, let's look up Kalim on TikTok. Kalim.am. For all the Kalim fans, Oh, you say, Kalim, what's your web page, boy?
Where's my like what you mean, like my TikTok page and stuff like that?
Yeah, I seen Kalim.am.
My web page is just Kaleem.a.m, or you can follow me on TikTok, Kaleem Kaleem .a.m on TikTok and on Instagram. It's the same. You can't miss it. It's
All
the
right,
same.
good. So all the people who say my baby had no Kalim and come back, Kalim.
Yeah, I'll go and follow me because I literally do a whole video to promote this thing. So I'll go and watch it. It done already. I posted like around 6:30. It done already on 3K views on TikTok and Instagram. So I'll go and make it blow it up. I'll go do well though, fellas and ladies and gentlemen. Yes, sir.
All right, my blessings. Thanks for popping in. Thanks for the video too.
It,
Yeah, later. All right, people. The grind is real now. We had to go on double time. So one of the terms, lock in everybody. Type lock in if you're locked in. One of the terms state that the angle in a semicircle, and this is one of the easiest terms to see. The angles in a semicircle is what? That's term one. The angles in a semicircle, the angles from a subtended from a diameter will always be 90 degrees. Second term is I had something that I made on this, but I'm getting problems to post that one, so that's why it's not on the website yet. So sorry about that. The idea with this one is like, all right, so this is always 90 degrees. This could be any angle, but there's a rule here. The angle at the center is always twice the angles at the circumference, or double the angle at the circumference, or the angle at the circumference is half the angle. So if I have this as 110 degrees, then this has to be 55 degrees. Why is in the chat if you all understand the first two? Everybody locked in with the first two? Another one of the baby theorems is this one. If we have, I'm going to give you all one just based off of these three terms just now, right? If we have this, we call it the Batman theorem or the Bonnier's theorem. The angles subtended from a common chord in the same segment are equal. So like if this is 40 degrees, it means this is also 40 degrees. So that's just three terms. Let's see if I can cook up something for you all just based off of these three terms. I could take off this headphones thing now. Just based off of these three terms, I'm going to cook up something. Everybody lock it. So I have a circle and I have this line, and then I have this line here, and this line here, and this line here. Actually, let's make it go here and here. This is the center of the circle. There's another theorem that I mentioned earlier that will come in handy in this, right? If I told you that this is not looking like 40 to me now. Let's say I told you that this is 50 degrees. I'm going to name out some things now. A, O, B, C, D. I want the value of angle AOD, then the value of angle ABC. See if you can get that. Let's go, let's go, let's go. AOD and ABC. Somebody say no, AOD is 100, and the person who said that not supposed to say that, eh? I'm not going to call a name because you're not supposed to be saying that. You're too good for that. So I just say tisk. What is AOD? So AOD, I'll give you a hint. This is a radius, and this is a radius. What does that make that triangle AOD? And if this is an isosceles triangle, it means this part here is also 50. 50 and 50 is 100. So what is this? The remaining, and I'm writing the full working because it's speeding, the remaining 80 degrees. AOD is 80 degrees. And then what is ABC now? ABC has to be what? Well, actually, we can never figure out what ABC is. We can never figure out what ABC is because ABC missing D. I play myself D. So I shouldn't have C there. I should have this going straight down like this. ABD. Yes, what is ABD? Yes, you are correct. Those of y'all who have seen what I was going to do, it is 40 degrees. If the angle at the center is 80, the angle at the circumference is half. Not double, half. It's smaller. It's squeezed in more. Class, are we cooking? Are we cooking, ladies and gents? Another one? You all want another one? More challenging? So, let's say I have this line, this line. These are straight lines. And I need a little believe me. Let's say I have this line goes here through the center. This line goes there. This line goes here. And what can I see? This is the center point here though. And I told you that this angle here is 42 degrees. A, B, C, D, O. And I want the value of ACB. Let's get the value of ACB. Let's go. Let's get the value of ACB, class. ACB. First, we need to know what ACB means, right? ACB means ACB. This angle. I need the value of that angle. Let's go. So we have some people zoning in on the 48. 48 is correct. 48 is correct. How are they getting the 48? How are they getting the 48? I said this is a diameter. That means this is 90 degrees. What else can we do? You see the bunny ears? You see the bunny ears here? If this is 42, this is a common chord. So it means that this is also 42. So we just like that, we have the two angles in this triangle. Finding the third one shouldn't be a problem. We have the 90, we have the 42. Subtract that from 180 to get. And all of a sudden you will see that this is 48. Why is in the chat if you understand? If you understand, type I understand. I got it. You see it? Time to bring in another theorem, ladies and gents. Time to bring in another theorem. Another theorem, and it's the theorem that you have to look out for immediately as you open the paper. So, sir, what question do you recommend doing first? Well, I recommend that you just go in the order of the questions 1, 2, 3, 4, 5, 6, 7, 8. However, I do recommend that you turn to question 9. Everybody should turn to question 9. And that's where the circle terms is. And check and see if there are circle terms, because January didn't bring any. Hopefully there are. And when you turn there, look for the theorems. So ladies and gentlemen, we have 2,800 people here. What is the OP advice I'm giving you? I gave Kaleem and them the same advice. Kaleem was just here 6 years ago when they were writing, and I was on YouTube back then. I gave them that same advice. What did I say? Open the paper, go to question 9 when you see it tomorrow, and write down all the terms you remember. Those of y'all who this is cooking you, go and watch the video I have on circle terms, because I'm only going to do a few more. I did a whole crash course on circle terms some time ago, live in the April lives. Or should I be here in the April lives? But anyway, I spilled milk because we can't cry about that. So this angle and this angle are supplementary. It means these two angles must add up to 180 degrees. For example, if I said this is 100, then this is 80 degrees. That's just how it is. That's just how it is. Right? Add up to 80 degrees, those two angles, they are supplementary. So it's opposite angles in a cyclic quadrilateral. Angles, I don't need to write it out. In a cyclic quadrilateral are supplementary, add up to 180 degrees. You just learn the technique. You all will practice writing it out for yourself, right? Or you should have had that done for yourself already. New question now, everybody. So I'm going to do this to the center, then this, then let's send this straight here, so let's send this here, so all right. Feel like I could bring this down like this, so too. Now we have some things we could play with here. So this is A, B, C. The ABC is a straight line. See if you can find what you think I'm going to cook up already. A, B, C, D, E, and this is O. And I'm saying that this angle here is 28. And I want to find the value of angle, a lot of angles. This is D, right? I want the value of ODE. I want the value of angle DOE. I want the value of angle AOE. I want the value of angle ABE. And then consequently the value of EBC. Let's go. Let's go. Can you figure out these angles? Let's go, ladies and gents. I can see clearly now, the pain is gone. It's gonna be a bright, shiny day. All right, so let's go. ODE, that's this guy over here. It's not too bad because this has to be at 90 degrees. Angles from a formed in a semicircle are 90 degrees. So if this is 28, this has to be 62. So big up yourself if you get 62 there. 62 plus 28, 62 plus 28 plus 90 will add up to make your 180. Big up your whole self. That's all out of 62s. DOE now. DOE, that's this angle here. What is DOE going to be? Well, this is the angle at the center. This here is the angle at the center compared with what? The angle at the circumference. From the common chord. Angle at the center is twice, so this is 56. So big up yourself if you was able to spot that 56. Not very easy. Easy now that I did it, but not very easy when you didn't see it. So this is 56. AOE, Attack of Age of Empires. AOT is Attack on Titan, right? AOE, Age of Empires. What is A or E going to be? Well, if this whole thing is 108, there's another way you could do it too. You could say 28 and 28 and then figure it out. But I think not 108, 180. 180 and we minus the 56. 180 minus, yes, everybody getting 124 here? Chat, are we cooking? You see why this has to be 124? So that's 124. I think we're cooking. And Abe. What Abe is? ABE. AB is a tricky one. ABE now. So maybe you're struggling to see ABE. I'm going to help you now. Remember, the number one, and this is why I want to, some of y'all going to say, wait, watch this. The number one thing, the first thing to do on your paper is what? When you get your paper tomorrow, the first thing is to go on to question 9 and look for them cyclic quadrilaterals. I just do too much solutions after exam and hear people complain about the cyclic quadrilateral being hidden. Opposite angles in a cyclic quadrilateral add up to 180 as supplementary. That's how you get that missing angle there. Fastest way to get that missing angle. So this has to be 118. 118 plus 62 will add up to 180. So that's this. And if this is 118, well then this has to be 62 degrees here. This is just your 62 waiting on you right there. Because it's on a straight line. You seen it? Are we seeing it, ladies and gentlemen? Let's get the last few rules out of the way. Remember, go look for your cyclic quadrilaterals. Practice it. So there's this rule with the tangent. We already do this a good few times. If you not with the tangent, with the radius, then you'll always get an isosceles triangle with 2 radii. Then this ruler doesn't really do anything in the exam. Perpendicular bisector will be the radius. So this is 90 degrees and it bisects the chord in 2. So you never really see this. They're the forever alone theorem. And then there are the 3 tangent theorems. What are the 3 tangent theorems to finish off? 3 tangent, that's not a circle. 3 tangent theorems. There's one that deals with a point outside that makes 2 tangents like this. 1, 2. Yeah. There's one that is just about a tangent. It's just like almost the rule of a tangent and a normal. And then there's the AST, the alternate segment theorem, which works like a tangent with with the point of tangency making a triangle. Like this. Those are the last 3 rules. So this one says that if you have a point outside of the circle, this line A to P and B to P are actually equal, so it makes an isosceles triangle. So the whole idea is this angle will be equal to the angle. That's what you really use in the exam when that comes. That's a rare one, but if it comes, it's very obvious. It makes an isosceles triangle. This one comes all the time. Tangent and a radius makes 90 degrees at the point of tangency here. This is called the normal. And this one is the rare Pokemon here. The angle between a tangent and a chord, is equal to the angle in the triangle in the alternate segment at the circumference. Or the angle between a triangle and a chord, the angle between a tangent and a chord is equal to the angle subtended from the chord to the circumference in the alternate segment, or in the opposite segment. So this angle here is equal to this angle there. One of the sneakiest theorems to spot. Call it the alternate segment term. Now, if you want the full details on this, see me write out all the rules and everything. Just search circle terms Kerwin Spring and watch one of the videos that I did this year. You'll get some of the latest on that. So let's add in a complicated circle terms question now and see if you all can figure it out. Let's see if we have some top dogs inside here. Boom. Boom. Actually, I think if I make a point and I make a point here, it works. Nope, it doesn't work. All right, so let me just, I don't want it to be a straight, or fine. Fine, if you want to be a straight line, be straight, my friend. Being straight is good too, you know, so yeah. And then, let's do this. And then let's do this here. People them want sequences next already. People them want sequences. Let's do this. That looks simple enough. Dun, 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 dun. What am I longing for? To make this question complicated. I wanted to put in a parallel line system in this question, you know, because yeah, let's do that. Let's make that this was parallel to this. Because it comes sometimes, and I just really throw people off. And then let's make this here. Let's make this here 40 degrees. Let me start to name up things. I feel that is all the information you need. PQRS O RS PQRS TU. So TRU is a tangent at the point of R. And I want to get the value of let's start off simple, SQR, everybody could do that. Then I want to get the value of QPS. Do I? No, I don't. OSP. This is a real good question. My CXC need to come check me. Come check me, bro. OSP. And then I want to get the value of PQR and then the value of QRT. This is a classic here. This is like the level CXC questions is beyond. This must be in your favor. I feel like I need money for this question. So SQR, OSP, PQR, and QRT. A lot of different terms thrown in the mix here. So SQR is nice. I'm seeing a lot of people nicing up SQR there. That's 50. And those who don't understand how they get the 50, because this is 90, right? Angles in a semicircle, the first term. It's a nice little 90 situation here. This triangle, this is 90. So if this is 90, 40, 50, it makes sense. Add up to 180. So very nice, very nice. I'll just smoke that. Somebody asked me if I bathe her morning. That is not the question. It's supposed to ask me if I bathe for the day. From morning is trivial. Ask me if I bathed since I reached Trinidad yet. So put the dot. Nah, what dot? Well, I don't know what dot you're talking about. All right. I actually did be there. Yeah. And it doesn't take jokes and things here. So we can't crack jokes here then. So matching the wall. You know you're going through it when you started to notice these things. You know they sleep You know, the sleep at a minimum when you just see me blending into the wall. So, all right, what is OSP? OSP, I'm not seeing any OSPs. I've seen only talk about everything other than what OSP is. OSP is 60. 60 altogether. Prove it. Prove it. I got 70, 40. Not much answers for OSP is like a real exam. Let me see if it's doable. Well, if you're struggling in the exam, like you're not getting the term, remember that there's three in this parallel situation, right? And this is kind of not on anything I just like in the last few seconds teach you about. Teach you about this parallel thing plenty times. We even do it a little bit of the bearings. This is the transversal. So if this is 40, that means this is also 40. It's definitely not drawn to scale because that's looking more like 50 or 60. That's how transversals work with parallel lines. These angles are alternate angles. So if this is 40, this is 40. I just solve it for the day. So yeah, what does this mean? This is an isosceles triangle because that's radius. So be very careful. And a lot of y'all, some of the top students struggle to get OSP. Real plenty of you struggle to get it 10 or so. Look out if they give you these parallel lines thing and look for these corresponding angles, alternate angles, or co-interior angles. Please, that's going to save you. So all of a sudden, everybody was able to start to spam the chat with 70 and 70. 70 plus 70 makes 140, and then the 40 will make the 180. So OSP is 70. We're cooking. And then what will be PQR? PQR now. PQR. PQR. There's no bunny ears here. There are no bunny ears in this question. Where's PQR earlier? 70. Seeing it? Why? Why? Remember the first thing you have to look for in the paper? You see it again. If you get catch again, I hope you understand the importance of looking for it. Cyclic quadrilateral. As soon as you open your paper, go look for the cyclic quadrilateral. It does hide. Opposite angles in the cyclic quadrilateral are supplementary. So if this is 70 and 40 makes 110, it means that this must be the missing 70 degrees to add up to 180. So that's how we get this is 70 degrees. And last but not least, this one is easy. QRT. QRT is what? QRT is every year without fail around 8 o'clock, somebody just lead the chat in a prayer. And I see it again. Somebody just, time to pray, fellas. Time to bring it together. Only God alone. So yeah, so 40 degrees. 40 degrees. Somebody's raised up a prayer. Get up. That person who raised up the prayer must be not even religious, But that's good. God must be in heaven. Hey, we getting a lot of prayers today. What's CXC? I forget CXC Maths. CXC Maths tomorrow. 40 degrees. All right, people, it's time. It's time to rule out and do something else. That's circle terms for you. You remember circle terms require the most amount of practice. Those of you all informed for watching this, you need to do as many circle terms as you can. Although we have some people moaning and groaning here, there are some people who are really good at it. The alternate segment theorem says that the angle, for those who didn't realize what happened there, the angle with the tangent and the chord is equal to the angle in the triangle in the alternate segment. So if this is 40, this must also be 40. Remember that? That's the final boss of theorems. And that, a lot of marks will fly here. So that might be 2 marks, 2 marks, 2 marks, 1 mark, or some kind of thing like that. Real marks win and throw it in this question. So it's time to do some statistics. We're coming down to the close. We're pushing through to see how far we could go. Statistics. Stats. We're coming up to the 3rd hour here. Statistics. So what you all want to learn in statistics? What do you know is the most important graph in statistics? Most common graph to come in statistics. Well, for the paper three, they bought a histogram already, and I was prepping you all for histogram. So like they bring it in the paper three, they might bring it in the paper two as well. But the most important graph is the cumulative frequency. There are six main graphs that you need to know in statistics. So if you're mind mapping, here are the 6 main graphs that you need to know. But before you know the 6 main graphs, you need to know about frequency tables. So frequency tables is a big thing in this, and like how to find the mean, mode, and median. So frequency tables, we'll talk about that just now, but the 6 main graphs are pie charts. So that's one, and that used to be an old school thing, but it's back to being really, really, really popular right now. Then there's line graphs, which is usually brought in the multiple choice. There's usually line graphs in terms of time. And the big bad cousin of line graphs is frequency polygon. But CXC can't make up their mind on what a frequency polygon is. Frequency polygon in most textbooks, in most areas of study, has a specific rule system that you must use, and CXC just be throwing it out the window and thing when they're bringing it. So it's line graphs, frequency polygon. Then there's bar graphs and histograms. They hear in zero scream, you know zeros want to be in these lives. Bar graphs and histograms. And I drawing them in order like this to try and help your mind map it good. So this is the nice cousins, and these is the bad boys. And excuse me, this is indifferent. These have nothing like a pie chart, right? A pie chart is a pie chart. So 1, 2, 3, 4, 5, and what's the last missing graph here? The missing graph is the cumulative frequency curve. Cumulative frequency curve. So a quick look at how each one of them look. Excuse me, a quick look at each one of them. So in the line graph, this axis is usually like time, and it's usually in years, and it's like for production. So you have like a line graph like this, bap, bap, bap. And the main trick with line graphs is that they like to change the unit here. So they might put cars, and they might put thousands of cars. And it's very rare. This used to come back in the days, line graph. Frequency poly, so this rare. This is most rare out of all of them right now. Frequency polygon, but it's easy. Frequency polygon is similar to line graph, but it's done using the midpoint, and we'll talk about midpoint and all of that just now. It's done using the midpoint of class boundaries, and ideally, they're supposed to close down. So they're supposed to come down to 0 on both ends. It's doing the midpoint. So this is plot using the midpoint of class boundaries, and we'll talk about class boundaries just now. So that's the frequency polygon, similar to the line graph, that it's plotted using midpoint. This is plotted. So this types of graph deal with discrete data. For those of y'all who don't know, discrete data means data that has to be counted, categorized and counted. Like how many apples are in the bag, how many cars were produced last year. That's a count. That's what line graphs and bar graphs are for. That's what this side of the graph deal with. Everybody understand? This side of the graph is supposed to deal with continuous data, these types of graphs. I hope it helps helping mind map this, especially if you're kind of good already in this. This will be really useful for you to like understand what's happening. So frequency polygons and histograms are designed to deal with continuous data. Pie charts, what type of data you think pie charts usually deal with? Also deal with discrete. And what type of data you think cumulative frequency? Also deal with continuous data. Continuous data is data that must be measured. Like data that must be measured, like the height of the children in the class. Sometimes they mix it up. They as I said, CXC kind of blurs the lines of what you're supposed to use them for. So sometimes they'll use it for ages, like cumulative frequency ages, which is not necessarily the way that they do it, continuous data. But it's okay, we can live. So it's just to get a little gist of what they are for. Histograms, well, bar graphs look like this. Let's go back to what they look like. Just a little quick gist. A bar graph is stuff like this, and notice how they don't touch. equal distance apart for a nice look. And this might be like pears, apples, bananas. And they will ask you about mode and the average, and maybe you might leave out one and you had to draw it, and you're doing this in primary school, to be honest, and really easy things. Histograms is more piece. Histograms, they touch, and it's continuous data, so it's a number line. A number line system, and those of y'all who know, see me do it already, you know it's the 0.5. It deals with the class boundaries, specifically the upper class boundary for most of them. And you draw the class boundary, so it's be a little 0.5 away, either forward or backward, to draw your histograms, and they touch. And I show you. Why is in the chat if you were here when I drew a histogram and I show you the proper way how to draw the histogram and the little shortcut techniques and things. You could go back and watch it, right? The cumulative frequency curve, that uses the upper class boundary as well. And it's, as the name suggests, it's a curve. It looks like this. And the shape of the curve is called an OGIVE. On this axis here is the cumulative frequency, which is a combination of the frequencies coming down, a sum of the frequencies coming down. All right. So, what we going to do, boy? What are you feeling to do? These are the graphs, and you have to know, before you know the graphs, you have to know like the frequency tables. So you have to know like a class boundary, and how we'll do like a frequency tally if you had to do tally, but tally is baby thing. That's like this. Close the gate, 5, 10. And then you need to know fx, or sum of fx, and what that means over the sum of f, and what all of that means. So I think a nice way to get the most amount of value out of this, and let me know if you all think this is correct. I think this is correct. Is to go from scratch, do a whole frequency table. So I'm going to take raw data. What you plan? I'm going to take some raw data. I'm going to do a frequency table with the raw data. I'm going to show you all about Q1, Q2, Q3 again. If you don't know what this is. If you don't know what this is, pressure in the camp. Pressure in the camp. Lock in. Lock in if you don't know what this is. Prayers. Prayers. Sorrows. Prayers. So raw data. I'm going to take the raw data, change it into a frequency table. And then I'm going to do two things. I'm going to make a histogram with it. And then I am going to make a cumulative frequency curve with it. Cumulative frequency curve. Frequency curve. So I'm going to do this. You all okay with that? We'll talk about this, then we'll come back. That sounds like it did. This, when I've done this, I'll going to be ready for stats in the exam. One more thing I'll do after I finish off with that, I'll come back and do pie charts. I'll come back and draw a pie chart, because I haven't like drawn a pie chart with a protractor in a while, so that will be beneficial. So if you're ready, stay ready! Ready? Let me go. So you went in a class, and you take the ages of all the students. This is swimming class. Swimming class. You take the ages of all the students. And there were some 2-year-olds, you know, in them class, they're teaching them babies and thing how to swim now. A 3-year-old, 4, a 6-year-old. Actually, there's a 2-year-old, a 3-year-old, a 6-year-old, a 7, a 8. Let me get a 11. 12-year-old. 14. How I want to do this, boy? I don't even know how I want to do this yet. What we feeling to do by curving, boy? 5, 10, 15, 20. Yeah, let's go in the 10s. There's a 16-year-old. Then there was a bunch of people in the 20s, 21, 22, 23, and next 23, 24, 24, 25-year-old, 36-year-old. There's a whole crew in the 36, 37-year-old, 38 and 39-year-old, 40, 41, 45-year-old, a 50-year-old, somebody else 55, and somebody else 56 and a 60. That is it. How much people in the swim class? How much people in the swim class, Alia? Let's actually the mode, is the mode, right? What's the mode? Like if this is raw data, you call this raw data. The data raw data. How much people was in the mode? If you have raw data and you have to find the average, everybody know what to do with this. Actually, you have it in order. That's the mode there. Because you have most 36 or 28. 28 is the mode, not 30. If you want to find the average, you add up all and you divide by how many people? 28. 1, 2, 3, 4, 5, 6, 7. 7 fours are 28 people. You divide by 28. You know the drill. But they don't really ask them kind of easy thing. Not them baby thing. Them don't be on that kind of baby thing, I tell you. So what they'll do is bring up this class interval kind of vibes. So let's examine what the class interval vibes is about. So Lord, give me the strength today. So we have 1 to 9, 1 to 10, 11 to, this is a classic one, right? 11 to 20, 21 to 30, 31 to 40, 41 to 50, and 51 to 60. And then you'll have to populate this. Why I put so much of this for, boy? Stressing out my own self, Cool. I'll let you close to 3,000. Let's see if you can make 3,000. Now press subscribe. Here's how to make it happen. Press subscribe. Everybody press like. How much likes we have on this? And send it to all the maths preparing. If you're in the student hub, feel free to send the link on the student hub group. I give you permission. Send it to your class group or your friend group and tell them all they lock it. You don't want to send it to them. You feel that kind of way. Send it to them. If your neighbor house on fire, put it out. Send it to them. Send it to them and say, I'm sending you this because your house on fire and we're going to learn some things. We're going to learn some things about statistics now. Lock in, you need it. Class interval. And then you could sometimes put tally, but I'll skip that out, right? That's easy. I'll put frequency. The tally is where you're going to do this and count it up bit by bit. But I'll just go straight to frequency, right? Frequency. I don't know if I'll hear him, but my youngest son downstairs quarreling 100 with Alexa right now. He and Alexa always going at it. Alexa, play chicken banana. Yeah. So anyhow, 1, 2, 3, 4. 4 in this category. Agreed? 1, 2, 3, 4. Another 4 in this category. Interesting. I didn't want that to happen. 1, 2, 3, 4, 5, 6. 6 in this category. 1, 2, 3, 4, 5, 6, 7. 7 in this category. 8 in this category. And 1, 2, 3. 3 in this category. 3 in this category. I want to change up this thing. So I'm going to make you 50 and I'm going to make you 52. So let's make it 4 in this category and 2 here. Because I fed up with the last 2 being the same numbers. Agreed? Agreed? Now, what you're supposed to do every time you finish up this, you can make a mistake. Double check and make sure you have the same. Let's see, reach 3,000. Bless up. Bless up. Press like. So 10, and 12, 22, and 6, 28. So yeah, we're good. I just double check to make sure that I add up to 28 because I know I have 28 people. Somebody type in 6, 7. Whole day we're going good. I didn't really see any 6, 7s. You come out here to type 6, 7. I feel any shame for you. You know, I feel any second-hand embarrassment for this person, boy. Take a little time out there, boy, because right now you're disrespecting your entire country. Imagine how much it is. 3,000 people here learning maths and you type in 6, 7. You take your good fingers that your mother take 9 months to make and press 6, 7 in a chat in a maths live. You're freezing up my chat, all kind of thing, boy. Shame. sheep, 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 sheep. Check. Why am I here? Check. Sheep, 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 sheep. Sheep, 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 sheep,